The old man built. The old man built. The old man builds. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man.
Hello, everybody, and welcome. My name is Nathan, otherwise known as Old Man Builds. We have Heliarc here, and we have Tim from the Timtron channel. Guys, what's going on?
Well, you first, Flint.
Yeah, it's going great, man. We went swimming today, and yeah, me and my daughter. So we got quite a few projects planned. Me and Tim was talking about it.
More working on the diesel generator, or did you already finish that one?
Yeah, no, I still got to finish that one. I got two of them, the little one and the big one. Damn, I just lost what I was thinking about. Yeah, I finished up some of the small components for it, and I got the case. I can't show you all the case for a while, but I got the case finished. It's gonna look like look like it came out of the factory. Yeah.
Well, there you go.
Yeah, I
like that.
Yeah.
Made in Texas. That's what I'm talking about.
Yeah.
Everything nice and clean looking.
It's gonna. I'll show you when I get it together. It's gonna be incredible.
Nice.
Because it's pre-paint metal. A lot of the sheet metal's pre-painted. So.
Okay. Yeah. Very cool.
So where did we leave off the last time?
So we were talking about last time. We were talking about the B.I.T, and just so everybody knows, we were talking about a motor generator combo, and then it was creating what is like I would call a mirror. So it would resonate one side, and then the other side would catch the resonance, and then it would go in. I want to say the core itself. So and then we're talking about the motor, and then we went on to the solid state version, and you said you were running your house on it for a while.
My first version, I ran an RV actually. Yeah, version 1. The first one that was functioning. What's nice about the B.I.T is you're taking the ECM, the AC output from the ECM, and you're driving the B.I.T and using that phase shift, capitalizing on that phase shift, resonating it, and dumping it right back into its source to continue the loop. So you're going to take the output of that B.I.T and you're going to use that to that current and voltage to drive the speed controller, which is going to run the Samsung, which is the prime mover.
Nice. So it runs the is it run the oscillation and
with the B.I.T that I was using, that's not to cut you out, Nathan. It was 200. I want to say 276 watts in, and or that right around that area, and 594 watts out.
Oh wow!
Yes.
So you doubled it.
Yes. Yeah, smidgen more than double. Yeah. Which is not a bad B.I.T. It's a pretty good B.I.T. Yeah.
Yeah.
So, and with the phase shift, what's nice about the phase shift, it's you're stealing time, and you're eliminating that when you close the loop on something that tries to kill itself. So you're making the system not too conscious or not too exposed to feedback because of the continual load. If your load is less and you're getting more out of that transformer, then that's more power for the prime mover. So what happened was it started to run away on me. Like Yes, and when that happened, I only had about 40 seconds to play with it before I had to shut it down because I was going to be in over voltage on the speed controller, and then that wouldn't last. So
Oh, well, it
it was
shuts you
time.
down permanently.
Yeah. So my when the next time I do this type of system, I'm gonna have full control over it. Yeah. Um, and be able to control and keep it from running away because it would have ran away until it destroyed itself.
Mm.
Yeah. As funny as that sounds, it's like um, I was amazed. Yeah, totally amazed. It's like, oh my God, this is a tool. This is like this 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 a bit will turn a system into something that where you don't have to worry too much about details, and you add the bit into it. And what I mean by details, characteristics of the generator and the alternator, or the motor, the prime mover, whatever you want, how you want to look at that whole system. um, you can have this continual load. When you load up when you're drawing more current out of it, the prime mover's input current's going to increase. And so the bit removes that feedback so it doesn't kill itself, and it actually makes it um, easier to move ahead, to get turned faster on RPM. Yeah.
So is it removing the
Feedback is
resistance in the
severed.
circuit?
Hmm?
Sorry. Is
Like,
it removing the resistance in the circuit?
no, it's all phase shift. That's the key to the bit. The phase shift. So you're taking you're ultimately you want to get real power out of the bit and be reactive coming into the bit. And when you pull that off um, with the right resistance winding, so maximizing like on the 230-volt setting rather than the 120, that would be my input side. That would be my primary of the bit, and the output's going to be my lower winding, but more current. Um, and then with the phase shift, it's a motion. A bitoroid bit is a motionless system without magnets. That's the best way I could describe it. And what's happening is what's beautiful about the bit is you're giving a spot. You're creating a void. Um, if you're going to drive C, you're not going to do anything with B, and you're going to resonate A, pole A, and that's where the magic happens there because you've got a big phase shift, and you're filling caps, and it's easy to fill caps
Mhm.
than it would be a resistive load. So you're converting that into DC, and then you're driving the speed controller, which is controlling the Samsung washer motor. So normally there would be if you were on the edge of free run, like really close, or maybe just a teeny bit over by a watt or two. That's that the system will run, but it's lugging and fighting for all it can. But when I threw the bit into that equation, now I'm using less power. I've got more output, and that's all going to the prime mover to turn it faster, and that's what happens. It just wanted to run away in RPM. Yeah, until the speed controller couldn't take the high voltage. Faster the system got, the higher the collected voltage from the ECM, or from the actually tail end of the bit would be rectified to DC. So that buildup is quick, and you've got to get rid of it somehow or find a way of controlling it. So
So when you say pulse it, are you, or excuse me, when you said phase shift, is it like a pulse on each coil in order to get
well,
that?
what I'm playing with the idea, I've got pure sine wave inverter apart, and I'm looking at the chip, and I think I can make the inverter go from 60 hertz all the way down to like 15 or 10 as a
Mm.
minimum, and be that an adjustment. So with a nice circuit, I can control that. I control the cycle rate of the inverter, which is going to control recovery rate going through the bit. So I'm going to be controlling the bit now. And then that output will be regulated going into going into the speed controller. So you get a nice controlled system that way. That's my plan, is to change the frequency of the inverter,
So
or maybe even make my own H bridge and do it that way. I haven't decided, but I looked up the chip in the inverter, and I can see in the circuit it looks like it's easily manipulated, so I can change the frequency pretty easy. Like just an extra pot and 3 wires and a cap and one resistor, one potentiometer, and I can make it adjustable.
oh yeah.
Yeah.
So did you find at lower hertz that you got a better result?
No, what you're doing is the slower you turn the slower you turn the generator, or the slower you switch something, the less output you're going to get, right? So what
Mhm.
I want is a way of throttling my input to the bit. And the best way to do that is through cycle rate. So I'm only going to have so many cycles a second in recovery going through the bit. So that real power out of winding A is I'm controlling the outcome of that part of the system, where how much current is going to be going into the cap. So based on the load of the motor, it'll level off to where I can actually drive the bit a little more and make the motor go faster, or keep it at that RPM.
Mm.
So regardless what's happening with the input voltage, I'm still controlling the output. I'm doing it through cycle rate.
Gotcha. So it's like a merry-go-round type of thing. You just turn it and then only push it when you need to, and
Uh,
it returns the rest of it.
Kinda. It's just picture the inverter as a picture the inverter for a minute as a buck boost. So you're taking the buck boost and you're regulating the output of that buck boost, and you're limiting the current that you want coming out on the output side of that buck boost, right?
Mhm.
Okay. So with the bit, if I control the frequency coming into the bit, and ultimately the slower I switch that sine wave, the less recovery and the less current and energy will I get out of the bit. So I can adjust the frequency of the pure sine wave inverter to increase the speed, because there's going to be a load at the other end of that bit. It'll be rectified to DC, and then it'll see the caps, and then from the capacitor bank, it's going straight to the speed controller and nothing else. So with the machine operating and turning, there's going to be a consistent baseline, a load of whatever you're running at that moment.
Mhm.
And so if you wanted to make it turn faster, well, increasing the frequency of the inverter will give it more output at the other end of the bit, which will drive the prime mover harder and turn faster.
Yeah,
That's the
he's
way
trying to regulate it.
I
Yeah,
want to control the bit that way and
it's
cycle rate.
hard to regulate people because I know there's not a lot of people that have made a looper like a real one, and so they don't know how difficult it is to control that once it
Right.
starts looping. It's
Hmm.
actually very difficult to control, and that's what Tim's talking about. Just one of the ways. There's a few other ways we've talked about of how to regulate that, because if you don't regulate it, you'll end up burning everything up, all your controllers and everything, unless they can take that high voltage. So.
Yeah, I was finding myself decreasing. This is what was going on when I had run away. I'm decreasing the RPM potentiometer on the speed controller. At the
Mhm.
same time, I've got my other two fingers on the buck boost, and I'm hitting the down button to decrease the output from climbing up. And then I'm watching my main cap bank voltage on that, and I can't let it go over. At that moment I couldn't let it go over 80 volts from the speed controller I was using, and the average was like 45, 50 volts. 51 volts was like the sweet spot that it really wanted to run at. And so once I got close to like 85, I'm like, I'm killing it, because I'm pulling the alligator clip off the cap bank from the speed controller because it's going to destroy itself. It just
Mhm.
can't handle 90 volts. If you go over 80 something, then it's done. Yeah. So I was
Yeah.
trying to avoid that, and then ultimately I ended up ruining it, trying to see how far I could go to see if I could throttle it back some more, and it wasn't going to happen. So I came to the conclusion. I thought about it for a long time, and I came to the conclusion that the only way I can effectively control a bit is its frequency.
Hmm.
So being able to sweep a bit with pure sine wave is really a nice tool for even tuning it. Because I might find that 60 hertz is not what I want to do, not the frequency I want to run it. It could be 150 or 120. As a matter of fact, sweeping it with an amplifier, I saw a sweet spot around like 150, 160 volts. So,
No, I saw that video because you were over there with the frequency generator. You're turning it, and you're getting a sound out of the transformer itself.
oh yeah,
And yeah, you would
yeah,
hear the pitch go right up and right down and everything, and you get that real sweet spot where it's humming.
right, yeah,
Wheel like a pig, like Hector says.
yes,
Yeah,
squealing
get
like
it
a
over
pig, and it
enemies.
literally does. You think the thing's gonna start going on fire and overheat and everything else, and it's just really resonated in the core. Actually, I mean, the thing starts to become a 60 hertz speaker. Is what it's trying to, it's just resonating the sound. Yeah.
Well, I found when you start to balance things in a system, the heat starts to go away. It just runs it cooler because it operates at the frequency it wants to be at, not what you want to put into it, but what it likes to operate. So the heat itself kind of goes away because it's oscillating perfectly.
Yeah. Well, again, with I think those anomalies exist because I've seen a lot of different things on YouTube where they're they were looked at their sweet spot and then they looked at some of their components and they were running actually a little cooler. And I think because of the junctions and like in diodes and all that else, transistors, um, when the circuit becomes in contact with cold energy, then you start to see that Peltier effect um, start showing itself, that's when you think about it, a diode, just running a diode in series with whatever you're running, whatever you're messing around with, and have a way of monitoring the diode temperature um, with some kind of either thermal paste or a thermistor on there, or do it with infrared. However you want to do it, however you want to monitor it, and compare from ambient temperature in that room to that. And the diode is actually a detector. If you want to look at it as a detector, it can be a detector. You're passing the current through there, but if you do have cold energy involved, you're going to see it in that junction. That's where it's going to tend to want to be a little cooler than ambient air pressure, ambient air temperature around it. So it's a detector.
Well,
It's not just a diode, it's a detector. Yeah.
yeah. So what I found was that when I lost the resistance in the circuit itself, everything got colder. Like when you're running the voltage mainly and you reduce the amps, it always runs a little bit colder, right? So that's the difference between NPN and PNP when you run them. But
Mm-hmm.
the good thing is when they're in resonance with each other, it now wants to flow the system. It wants to pull the energy through it, is what I found. And the circuit will actually change from the temperature in the room and start dropping 10 to 15 degrees easily in that circuit. And the resistance is gone throughout the whole thing. So, one, for instance, is if you get a spark gap in there, your spark gap usually runs about 240 degrees. It'll run at room temperature if you remove the resistance from it because it won't have time to build up any heat or any amperage in the wrong spot in order to ruin the circuit and slow it down.
um, yeah, there's no doubt in my mind that those are anomalies. It's an
Yeah.
anomaly that um,
There's a
most
lot.
people, some people can accept.
Well, those are the ones we're looking for, aren't we?
That's why
Isn't
we're
that
here.
the yeah? It's the whole goal of this whole project to do anything like that is to find
Hey, you
those
know what's funny?
anomalies.
Every time I use my vape, the switching noise that comes off the vape actually blocks my Bluetooth signal for a second,
Oh,
and it makes my Bluetooth headphones disconnect. Isn't that weird?
yeah,
Yeah, just disconnected again.
yeah. I think we look back on it, and Steinmetz tried to kill all these anomalies out of the system just so we can get the Tesla system to run. And what I think gets lost in it is every one of the anomalies, instead of just killing them out of the system, they should have worked them out and run them and find out why. I think what he found out was when you start doing that and you get rid of those things and allow heat to build up, then you can charge more people more money. Is what it is on
Mhm.
all everything, because now it's a loss. It goes out in heat, and they have to buy more.
Right. It's all about the
Yes.
almighty dollar.
Yeah.
Yeah.
So I
So
was wondering.
I was wondering one thing, Nathan.
Yeah, go for
Is that R2D2 behind you real deal, or is it just?
it. It's a Pepsi cooler.
Oh, okay. I thought you
Not
were
being
doing some
better.
serious stuff over there.
No, no. So I worked for Pepsi back when they did the Star Wars promotion for the second three films, and we used to go in there and set up displays and stuff, and they had the life size figurines and stuff that you had to put in the store. So we did that, and they gave us some R2D2 coolers and stuff like that. So my wife won't let me sell it or get rid of it. She says it's hers, so it sits in the background.
Well, I don't blame her. I don't think you should throw that out. I think that's probably worth like $27,000 or something. I saw one, I'm telling you, I saw one on eBay a while back, and it's like, what? That's what it
Really?
did. Yeah. So,
Oh man.
yeah. Don't let the wife know. Just think of all the stuff that you can buy
Oh
that's
no,
worth.
no. But just let it sit there. She'll find out eventually.
Yep.
So
Yeah, I've got at work. They've got. I'm sure you guys have seen them. They're plastic drink cups. They're about this tall. I don't know. They're tall, like 2 feet or something. And they almost look like a bong type setup where they got a drink thing on top, and then it goes narrow all the way down to a
oh
bowl on the
yeah.
bottom. Yeah. Well, they're plastic, and I've been collecting. There's like two different sizes they have there because I visualize I visualize making Tesla coils on all of them, and I probably want to do this like on a three foot square piece of plywood, and so identical, like maybe nine Tesla coils all the way around, and in the center one. They're all identical now. They have the same size capacity hat on top, same number of turns, same wire gauge. The primary, I plan on having a primary tuned on the bottom of all nine of those. So
Okay.
my theory is drive the one in the middle. So now you have no physical connection. But on the bottom of each capacity hat for each Tesla coil in the high voltage side, the high voltage winding, I've got these little glass envelopes that I think the spacing is like 25 thousandths of an inch, and it's a spark gap, but it's in a glass envelope. And one side of it you can actually bolt it to something as a heat sink, and so that's a fixed spark gap. So picture all nine foil balls, whatever I use for a capacity hat. Um, those are all these building up charge and then going through the spark gap and then into the high voltage winding. Now, the bottom of all nine Tesla coils, including the one that's driving in the middle, is they're all going to share the same ground, the same common.
Okay.
So on the primary, all 9 of those coils. I want to resonate with enough capacitance and take that output with high voltage diodes and combine the output of all those primaries, whether I put them in series or put them in parallel, whatever I want to do with those, I can do that. And then take that output and share some of that output and keep driving the middle one. There's no physical contact, but yet through the ionic connection and being in near field, they're all going to be connected. But the one that you drive in the center is not going to see an increase in load, and that's what's going to be nice about it. So you've got a looped system. Yeah.
So
Very simple loop system, but it would be like the Russian catcher, except now you've got 9 of them all the way around one.
right. So I was just doing testing today. When you set up your Tesla coil, the number 1 coil will go into any secondary that sits around it and start driving it. So I don't know necessarily that you need a number 1 coil to go around every one of them, because you'll start getting magnetic anomalies that they'll, you know what I mean? It'll off the frequency of some of the other ones.
If all 9 coils are on that same radius line and everything is even between all of them, so everything is proportion, the capacitance value, because of being close to each other, everything will be the same all the way around to the center. So you're going to take advantage of that. So there will be some coupling because both coils are going to be the same polarity.
Right.
So there will be some kind of coupling going on, but it's those lines that are coming off the high voltage coil. If your coil is on, your Tesla coil is on here, all these lines you're making a toroid. There's a magnetic field that's being generated. So you're going to have electrostatic, and then you're going to have that near field. And I think 9 would be probably nice. Maybe more, maybe less. I don't think 9 is significant, but to be an even amount all the way around the 1 Tesla coil that you're driving that's generating your energy in your field, you want everything to be as perfect as possible all the way around that. Like when it was running, I guarantee you, if you stood into it and got close to it with your hand, just stray capacitance off your body will disrupt it.
Oh, it will. So I'm not disagreeing with any part of what you're saying, except for how you drive all of them, because I think you could put the driving just on the center coil in the center of it and drive all the coils at once.
Yes,
with that one winding.
Yes. So you've got this is 1 Tesla coil in the exact center of the wheel, and then you've got 9 Tesla coils all the way around it on the outside, evenly spaced to the center and to themselves. So no physical connection from the driven one in the center. That's going to create the field for these 9 other Tesla coils.
Exactly.
So if all capacity hats are the same diameter, whether I find a kid's toy in the store and get 9 of those and glue foil on them and make the same capacity hat. So if all the coils have the same number of windings, the same diameter, the same material, same everything, all the coils will be identical and they'll all be resonating at the same frequency, whatever that frequency is, whatever it's naturally wants to run at. That's the key. And so you're going to have the near field you're going to have that signal, that magnetic field coming around that's going to want to couple into them, and then you're also going to have the electrostatic. So you're going to release the copper electrons when you have the spark gap from your capacity hat off all 9 of your Tesla coils. All that happening at the same time, whatever that value is coming into the coil, it's going to be added up 9 times, but you're going to have no physical connection to the driving Tesla coil in the center. So you're looping that field, but you're not making a physical connection to it.
Right. I 100% agree. I actually saw it work today. So I had a driving coil and then 3 secondary coils with no number 1 coil on it. And each one of them shot out plasma from it based on just the original center when driving it. And you can drop those right into caps easily. And if you make the coil in the center bipolar, and all of them then would be bipolar because of where the field comes from on the number one, it'll actually give you more amps than volts. It's because it'll slow down the oscillation to each one. And then you get a heavier amount going into your caps. So it's just something to think about, unless you want it mostly voltage. But I don't know if the cap cares. It just fills up.
Yeah, they will. If you're going to try and deal with high voltage, with all 9 coils, all 9 Tesla coils, and the 10th one in the middle, if they all share the same common, and with the capacity hat on all 9 coils, and then you have the spark gap, so everything you do to the center is going to happen on the outside. But because of all 9 coils, you put a primary, and if you resonate that primary with the right capacitance value and tune them, you can tap all those primaries, and that's now your secondary on your outside ones. So your original primary, if you were going to drive that Tesla coil, is now your secondary, because now that's where you're going to tap your power from. And you could series those up, because those are going to be sitting there isolated from everything. It's not going to make
talk about no wire system.
Yes, but yet what you're doing though is you're capitalizing on the near field and electrostatic, and so you're going to have these ions flying off this thing, and it's just going to be probably smell like a spring day. You'll have a lot of ozone in there, but I guarantee you could loop that system. It's not gonna know it's driving. It's not gonna know.
Well, it's not going to care, especially if you put them all at the same frequency on the number 2 coils. Right. They won't care one bit. They'll do it real fast and easy without resistance. Yeah. You'll actually pick up energy by making sure everything's in resonance with each other.
Yeah. So if the center coil that's in the center of the axle, so to speak, as long as all 9 Tesla coils are identical to that in every way, they're all going to be resonant at the same frequency. And so whatever that sweet spot that you find on the center one, that's the frequency that you want to run it at. So you're going to find more output and less input. Your input current's going to go down. You're going to find a sweet spot through resonance, because your 9 Tesla coils on the outside edge, radius and all around it. You'll see a sweet spot where I guarantee you the effect of the capacitance off your body could disrupt it. And that's when you know you're the best that you can get right there. You know what I mean? Because if you can influence, that's your capacitance from your body or from your hand. That's a very, very high Z situation. So very, very, very high resistance is still affecting it. And with capacitance, let me put it this way: you can fool an ohms meter if you're ever up around, say, 10 meg ohms. Excuse me, 10 times 1,000 meg ohms. That starts to starts to look more capacitive than resistive, but it's the same thing. So that's that near field from your hand. You would actually detone 1 or 2 of those Tesla coils on the outside just by getting near it.
Right.
So when you're tuning that system up, you're probably 5 feet away from it. All your control is 5 feet away to be able to drive that and control the frequency.
Well, I found 2 things that may help you. When I was doing it today, I resonated 11 feet from a driving coil to just a number 2 coil just hooked into ground. I got 11 feet of distance, and when you walk in that field between them, you'll interrupt it, no problem. And you'll set off the light and everything like that. I did find, however, that if you put in a second sleeve on the inside of the original Tesla coils, then on that number 2, it'll actually help it stay in balance. So your body capacitance won't set it off as much because you're adding mass to the inside. So
Yeah,
it,
what that is there. If you take, you're talking PVC. What kind of plastic?
yeah, just PVC.
Yeah, if you put that in the microwave for 10 minutes, put a small fit in the microwave and put it in a glass bowl that you don't care about, and put it in the microwave for 10 minutes. It's a great dielectric, but it's not good. So that's why whenever I've built any of my Tesla coils, I've done it on paper tubes. My best Tesla coil ever was on a paper tube.
Really?
Yep. Yeah. Yep.
I bet
Yeah.
some
I
of the
mean,
middle ones.
you want
Yeah.
that tube dry. You want to seal it. Then you put your wire on it. Then you seal it again. Um, and then you have something that's like You're not going to have any breakdown in it. You
So
know, it'll last a long time.
if you take one of those tubes, would you varnish it just slightly to give it a coat on there before you wired it?
On a paper tube?
Yeah.
Yes. Oh yeah. No, you want to prep the tube. Yeah, you want to dry it out, whether it be in pieces and you're putting it in the oven on like your lowest setting, and you want to take you want to suck the moisture out of it, so that when you spray it with clear, it's sucking in and there's no moisture in there. Then maybe a light sanding, and then smoothing out any imperfections or whatever that that'll get in the way when you're putting the wire on, and then you coat it again. Yeah, coat that wire again after it's done. But you're going to turn that cardboard into, you know, you're going to stiffen it right up.
I'm gonna have to try that. I've never done it with cardboard. I'm
Yeah,
gonna have
I
to
made
see the
it.
difference.
I think it was 18 inch. I found an 18-inch tube one time, and I took a 10-foot chunk of it, and and I made a Tesla coil out of that, and that was, I mean, that took, I forget how much clear I put on that thing. I think it took me almost a year to make it, almost to build the tube, just about a year. But it was worth the wait because I was getting 30-foot arcs off this thing.
Really?
I was horrifying the neighbors. They didn't know what the hell was going on. Yeah, they were horrified.
Well,
Hey, has
yeah.
anyone tried glass? Pyrex? Have you ever tried making one out of a Pyrex tube? Because glass is
I
very
have.
good.
I
You have
bet you
to?
that would be nice. Yeah, I bet you that'd work good. But I
You
mean,
gotta
there's
make.
no way of knowing. I mean, you can microwave paper. If it's dry, you can put that in the microwave and it's fine. You know. So to find out, the poor man's way to find out if you have a good dielectric, put it in the microwave or put a sample of it in the microwave and see what happens. Yeah, because if there's anything there to vibrate, you're gonna see it. It'll be in heat. You know.
So hold on, you're not just drying it in the microwave. Are you saying it
No,
vibrates in there?
I'm talking. No, um, you throw your sample in the
Hmm.
microwave in a glass bowl for whatever whatever kind of plastic you want to try
Okay.
for a tube. You want to sample, see what happens to that in the microwave. So you want to find out if it's a good dielectric. The microwave oven is the perfect tool to find that out. You're just bombarding it with microwaves. If there's anything there to vibrate up, then you're going to know about it. If it's a good dielectric, it should be able to survive a considerable amount of time in a microwave without, maybe be warm, but it won't be hot. It
Okay.
won't be so hot you can't touch it. If it's so hot you can't touch it with your fingers, then you don't have. That's going to affect the frequency. It's going to affect the performance. It's a loss. It's ultimately a loss. It's a bad dielectric. Yeah, and there'll be leakage inside of that plastic to whatever sees ground or whatever sees the opposite side of its circuit.
All
So
right, Tim, you convinced me. I got to get one of those tubes, man. I got to find a place that sells them. Probably the UPS store for, plans and stuff. They probably have a good 4-inch tube. and then I'll coat it and sand it and coat it again, and then wrap it.
I got mine from a carpet company. Believe it or not, they had some fancy rug rolled up inside of it, and it was shipped. And when I saw that, it's like Tesla. You know what I mean? When am I going to do it? I don't know. What my problem was, the longer this tube, I was moving it out of the way all the time, and I said to myself, either I got to do something with this, or got to get rid of it. And I decided to follow through with it, and I'm glad I did because I used three different electrodes, kind of like in this orientation. Each finger is like that. And what I did was I spun magnets on the plastic disc, so the magnets were actually pushing the arc out, blowing the flux was actually blowing the arc out, and that was my rotary switcher. And I could drive the thing really hard. You know those big neon transformers. They're about, I don't know, a foot and a half long. They're black and they're like maybe 8 or 10 inches high, and they get
Okay.
big ass insulators off both sides of the thing. And I think it's like 60 or 70,000 volts with a lot of current. So I had two of those. Yeah,
Nice.
I had two of those running it.
So you
So
ran it. You ran it in
my spark
AC.
gap. No, I had two. I took each transformer and I rectified that with high voltage diodes in their own cap bank. So each transformer had its own cap bank, and then that was brought into my spark gap. So my primary saw either high voltage transformer A's output or the second one. So it was constantly running from this one to that one in the circular motion. So 12 o'clock was one hit, 6 o'clock was the other hit,
Okay.
and nothing in between. Yeah. So I just used it was a small motor turning a piece of fiberglass rod that I had. I think it was 2 feet long, and that was a great insulator, and never had a problem with that. And then that ran out to a bushing that had the disc on it with the magnets, and the magnets just blew the arc out. Every time it went around, they would blow the arcs out, and that was my switching for the primary. And then the primary, which was actually it was inch and a half cold rolled copper um, that I used, and that was a pain in the butt to wind the primary. And I had 9.5 turns. Um, Used big pieces of um, the top insulators that you have on the telephone poles.
Hmm.
So I had a 4x4 post here, here, and here, and so four all the way around this coil. And every connection clamp that I had going over the copper went to the insulator. And so that's what supported the primary, and then the 10-foot coil was inside of that. And it was
So the secondary itself, was it? How tall was that?
I think it was like probably like around 30 inches, and yeah. So the coil was about 30 inches high, and probably almost 4 feet in diameter.
Mm,
Yeah. The
very
the
nice.
Yeah. I played around with being closer, and that seemed to be the great. Don't forget, the tube was 18 inches in diameter, so I tried smaller primaries and it wasn't working. The bigger I got with the primary, the more I was getting out of the top, to where it was like I thought I was going to get hit in the head with an arc.
So did you go 90 degrees with your primary?
No, no. You mean turn the whole coil on its side?
Was the primary flat, or was
Oh,
it?
the coil went around just like a conventional. It was a Tesla coil, a conventional Tesla
Oh,
coil
okay.
on steroids. Just picture, yeah, just picture this 10-foot tall Tesla coil that's got 1.5 inch copper wrapped around the bottom, wound around the bottom on 4x4 posts with telephone pole insulators. It was a pain to move, but
Oh,
yeah, it was actually a pain in the butt.
that sounds
Yeah.
really epic. I'll be honest with you. That
But it was. And you know what? When I did this, I think we still had friggin' Polaroid. It's like I had no way of documenting the moment. You know, I could probably get a hold of a couple of old people for a statement from them, and they'll swear to it. They'd be like, and then everybody's TV back then. When I turned that on, the neighborhood was pissed. Nobody saw nothing. Yeah, nobody saw nothing. Yeah, that was just like a major disruption to the whole neighborhood.
oh yeah, you
Uh,
got to find an empty field somewhere with huge
yeah,
empty field.
yeah. While I was doing that in my backyard, I didn't care about the neighbors. I had a mission to do, but the arcs that I had 30. If they weren't 30 feet, they were 25, but they were big arcs, touching the trees. Because I had it in my driveway, so I mean, I got trees on both sides. It's like trying to connect to the trees, the branches. Yeah, it was crazy.
Hmm.
Yeah, you got the ultimate fry it and find out, huh? Just just
Yeah,
hit it real
and I'm in
hard.
the city. I'm in the city of Medford when I'm doing this. So everybody's coming out their front door and they're going to the street and the sidewalk and they're just like looking like, what the hell's going on here? It's just, yeah,
You had your own
it was
lightning machine in the front yard. That's
literally,
awesome.
literally,
Yeah, I gotta try that, man. Yeah, if that really does push it that much further for that secondary to be at a cardboard, that's going to be huge because, like I said, I'm pushing a field with a one transistor and a resistor, and I can push probably 10 feet with it, no problem, at full power.
hmm
I had to put it at half power when I got 11 feet out of it. So I couldn't even push the full power. I couldn't get the distance far enough away from my coil itself.
yeah.
So I'm going to have to double that in order to get it. And I could probably push it right across that room.
What, like the coil that's by your left shoulder, that's behind you. What's the resonant frequency of that one?
This one right here, it's resonating at 320 kilohertz right now.
320.
Yeah, well, I shouldn't say that. It resonates about 280. The winding on it is 320. Sorry, I had to pull both numbers because I was trying to resonate the other driving coil to this one
hmm
because I built all the
So,
secondaries the same. Yeah.
so what gauge wire is that?
On this one, it's 32 gauge wire.
32.
Yeah, so it's actually I think 10 and a half inches of winding on it because I cut it at 11 and a quarter, and then I put tape on the bottom side and the top side.
Right.
So,
I think I used 16 gauge on the big boy for the
oh,
high voltage.
that's thick.
Yeah. 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 I didn't want to do. Yeah. I remember. I think it was 16 gauge, and I ended up getting the spool of wire from Information Unlimited in Salem, New Hampshire, and he had a big spool. Ended up giving it to a ham friend when I was done with it, and he was doing a bunch of stuff, winding chokes for trapped dipoles for ham antennas. But that wire was nice. It had some kind of orangey coat, and when you got through it was double layered with something, but it never bled through, never arced out to itself. That 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 Tesla coil was as good as the day until I threw it in the dumpster. That's where it ended up. Yeah, I put a hammer to it. Couldn't take it with me where I was going, so I was like, "See ya."
That sucks.
And I tried finding some people. Nobody was interested in doing that stuff. I would have gave it to them. So really kind of killed me a little to do that. 'Cause I put a lot of time into it. But that was big wire, and that had to be in proportion to the primary.
Mhm.
And the primary, I bet you there was probably, I mean, the rotary arc was loud. Like if you had 22s, if you could continuously shoot off a 22 gun, that's how loud it was. Yeah, it was loud. It made a
Oh
lot of noise,
man.
a lot of current going into that coil, and if you shut it off quick, you could actually feel warmth on the primary. It was getting a lot of amps, and I never even got to figure it out, um, to try and figure out how much power I was putting in it. But the outcome was, 25, 30 foot arcs coming off the top, and the top was two big mixing tubs that Dunkin' Donuts threw away for one of their big dough mixers. That was the capacity he had on it. I just screwed two of those together and threw a boss fit on the bottom, and that was my capacity hat, which was a big stainless steel tub that was the two
Nice.
together. So that was, I think, a little over 3 feet in diameter. Yeah, on an 18-inch diameter coil. It fit. It looked perfect. Yeah,
So
yeah.
you had no breakout pin or anything. It just went on
Oh,
the.
yeah. I had a piece of um, um, a stainless. I've had a piece of a stainless steel 102-inch CB antenna whip, and it was. I cut it. I cut it about 11 or 12 inches from the bottom, just above the top of where they had the 1032 screws. So I screwed that into a boss fitting that screwed into the top of the insulator, and it had a nice stainless spike on there. That was, I grind a nice point on it. So and then what's funny is the capacity hat and that spike. It you heard the electricity. I don't know how to describe it to you, but that thing resonated like a speaker, and it made a lot of noise. Yeah. So between the rotary spark gap, um, all that noise from that, and then the arcs coming off. I mean, this thing just looked like it was from another planet for an average person.
Was that number two humming?
Yes. Yeah.
Nice.
Yeah.
Dude, that would have been something epic to see. I'll tell you that right now.
Oh, it was. I was. It's like I stepped back many times, and it's like, holy shit! I built this thing. That's like I amazed myself because I really didn't think. And I was running it when I was trying to tune the thing. I was using just a small little ignition, a small little 10,000 volt ignition transformer from an oil burner. I was tuning it on that, and then I got brave enough. I put um, one electrode on it, then on one both electrodes from one transformer on there. Then I found the other one. That took me a little time to get that. Then I put that on the unused pins of the rotary spark gap. And once I got that going, it took me. I had a problem getting some high voltage caps, but that place that I bought a lot of other stuff, Information Unlimited, and there was another place in you got Salem, Mass, and then there's another place in Everett where I end up getting some high voltage caps and um, got to finish that. You know,
You can't really
but I
buy from
had.
them anymore. The
Are they
information
closed?
on them.
Yeah.
No, they're if you go to their website, it looks more like strictly a defense contractor now.
Oh, I could tell they were going that way. Yeah.
Yeah, I found some
Yeah.
slappers on their website. They took them down, but
Yeah.
yeah.
I was getting my Heaney. I had a 20-watt Heaney laser from them. I bought from them. That was fun. But the high voltage power supply was brutal. I was always fixing it. I could never get 2 or 3 minutes out of it, and I was, warm up the soldering iron and start changing transistors again. it burned everything I've tried running that with. And
Yeah.
it took I had when I got it, I had a mirror misalignment on it, and I don't think I ever got it perfect because if I had a one piece of 1x1 wood on the beam, like maybe 4 feet away, 3 or 4 feet away, it took a while to get out to burn through the wood. You know what I mean? So I wasn't getting not nearly what it was capable of, only because I could never align the mirrors right.
Mm.
I've spent so many hours. I remember spending a lot of time. One time I got it, and got greedy, and I went for another adjustment. And the neck that's on that. Once you make too many adjustments, there's nothing else to get because you're running Allen screws into a slot all the way around the output and that's on each end. And after a few adjustments, you lose control. You can't do anything anymore, and it's junk.
Oh, that sucks.
Yeah, yeah,
Yeah, I've had that one too many adjustments and something breaks, and then you're back to the drawing board again.
right.
Yeah, I had that last week. I was soldering stuff together, and it had to stack as it was soldering, so I can make just the shape. And sure enough, man, it's one bad mistake. Trying to fix the solder so it didn't look all crazy, ruined the whole thing. Had to start over.
Yeah. So what do you got going on over there, Flint?
I was gonna. Cody was trying to ask a question that you probably would be the best to answer since you're a radio guy, Tim. Uh, Asked, can your guest address the connection to the ionosphere acting like an antenna? To me, I thought it was more of a reflector.
Yes, it does act like a reflector, and then you got different layers up there. If you Google it, if tell him to Google it, or go to AWRL, and go to their website. They've got propagation maps there and charts to look at that will tell them everything. Certain frequencies, um, like I mean, if you're like for radio is HF. Um, in the evenings, generally the evenings are good. So you've got less noise, less electronic noise, and less disturbance from the sun um, for static crashes. But yeah, you can. That's why when you listen to short wave frequencies, some of them just kind of roll in as a wave and then they leave, and that's the right conditions up in the atmosphere. That's acting like a reflector, and then you're receiving it. You know what I mean? So
Hmm.
conditions.
And I had another thing I wanted to add in. Let me get to his name again. I couldn't find the video. I think he took it down or went unlisted with it, but his name is Alex Manzaro. It's this guy right here. He has the lens-free coil, but what he had set up is he had a high voltage source. It was like it's probably like basically like a Tesla coil. It was probably 20 kV, and he was sending that into a small 1-to-1 transformer, and then he was sending that. I believe it was rectified. He had the high voltage transformer in oil, like mineral oil, and then he was sending that to a DC motor, and then with that the motor would spin, and he was saying in the video, he was like, it's not supposed to spin at 20 kV, but it does. And no matter what he did to the other end of that shaft, it did not reflect back to the source. So it was a great video demonstration. It reminds me of the Tesla coil experiment y'all were talking about, where you're getting an isolation effect, except he was manipulating it to get rotational power out of a little DC motor. And I don't know how much, if he went further with it, because it's not on his YouTube anymore, but it was very interesting. I wished I could find that video. Because I wanted to try that experiment that he had going on.
Well, if you go to John Hutchison's YouTube, um, I've tried it and I know it works. Um, But he's got one video where I don't know what his elevation was or what he was doing. I don't think there was any details on the description of that video, but he shows speaker wire being hung up in a pine tree, and he's got a good ground, and he's taken just a permanent magnet motor. It might have been a 24 volt, low current, maybe a 4-pole motor. I'm not sure, but it was a permanent magnet motor that was, probably, I don't know, 4 or 5 inches in diameter, and maybe a half a foot long, or maybe even a foot long. And every time he touched, he had one lead going to ground, and the other lead went to the antenna. And every time he touched that antenna on the short lead that stuck out of the motor started to turn, and that's just collecting some of the ionic energy around him and putting it to work.
Nice.
Imagine that. This is I said. Oh, I've said it. I know definitely one time with Flint. It's like my dream is to have a nice house in my garage or my lab, and my backyard is an AM broadcast antenna that's 1,000 feet long, sitting on an insulator and has all the guy cables with all the insulation and
You can
because
collect.
I've done work at a AM broadcast station, um, but they're transmats for the load up the tower, and I'll tell you what, you can get killed by what's coming off that tower very easily to ground. There is a lot of power that can come from an antenna. And then you've got this place in Texas. I forget what town it's in. I think it's up north, um, of Dallas maybe, or somewhere in that area, or maybe a little more towards the northeasterly direction from the center of Texas. There is a big fiberglass tower with a big capacity hat on the top, and that's a giant Tesla coil that they're doing a spark gap, and they're tapping that. Yeah,
Huh.
and
Yeah,
then
Well,
that
it,
was
producing 12,000 watts of continuous energy. And I haven't checked on it for a while. I'm sure they were talking about coming up with maybe 100,000 watts. They were talking about building something else. They won't. I know a few people on YouTube. I think they passed away from COVID, but I know 2 people that went there and got chased away by security.
hmm.
Hmm.
So were they even running any driving system, or just pulling the energy out of the ionosphere?
No, they were tapping the energy and putting it into a load bank and making measurements. Yeah, real power,
Nice.
measuring real power. Hmm.
Yeah,
Yeah,
Yeah.
same as if you did a balloon, right? If you floated a mylar balloon with a conductive wire, it's going to eventually start shocking the shit out of you. If you're
Oh yeah,
young.
yeah,
Hmm.
yeah.
Yeah.
And just think, remember NASA did an experiment. I forget what mission it was with the space shuttle, but they had what was this wire, 3 miles long or 4 miles long, or I don't know what all the details were, but there was a lot. It was a big antenna, and that thing disintegrated in just one big flash.
Oh wow.
So that was connected to the shuttle, and they let it out, and before you know it, the thing just disintegrated. It just came in contact with so much power that cable was like a filament, like a light bulb, and just got overloaded and just blown apart. Yeah.
Yeah, that's so cool because it reminds me of Tesla's radiant energy patent, and then his Tesla tower. It probably pulled all the energy from the ionosphere.
Yeah, well, he's on the Earth. Tesla was on the Earth doing the same thing that the shuttle was doing in space. But you have to ask yourself, if you want to collect energy, if it's that easy, is it that easy to collect energy? Just just send this antenna out from the back of your spacecraft and have that power your engines.
Oh yeah.
You know, whether they be plasma or whatever kind of propulsion that's going to be. That's your power source. If you think about it, and who knows, some of these aircraft, the metallic value of these UFOs that come down, um, that's they've found a way of tapping that. I don't know if that's that. I mean, that could be the ether. I mean, really, nobody knows what dark matter is. Nobody knows what this energy field is. Nobody seems to really have put their finger on it. But we know that there's these anomalies out there in space that can't happen here on the ground. So
Well, Otis T. Carr said
potential
that.
power source.
Yeah, Otis T. Carr said that his OTCX-1 would be over Unity when it reached the ionosphere, and he was saying the same thing, that he pulled the energy from it and it was able to drive the craft.
Unbelievable. Yeah. So it's out there. It's around you. It's when you're walking down the sidewalk, you've got this. It's like the bird on the high tension line. He doesn't know he's sitting on 275,000 volts. It's just, or he wants to eat his seeds and shit. You know, he doesn't know.
Yeah, it doesn't care either.
Yeah, totally clueless. Yeah.
It'd be cool if you could make a drone that could go up, say 500 feet, and it could collect the ionosphere and run itself off of it. But you'd have to have a ground, or I don't know if you can make a virtual ground somehow. But I
Well,
guess you
why
could.
not? Why not make it two pole?
Oh yeah,
Why not have two poles coming out or two wires going out?
yeah.
Because
Well, I
now you
guess yeah.
can.
If you had one up high and one droop down, and you
Hmm.
had like a conductive something on it, like a ball,
Right.
say a sphere, and your difference was enough, I guess you could potentially run that drone indefinitely, just with propellers. Just
Well,
sitting.
I mean, put it this way: just the capacitance value of the space shuttle, whatever that whole surface was of the shuttle, that's still a capacity hat. The cable that you're letting out behind you, that's your antenna. So it's like a Tesla coil. You got a capacity hat at the top. You take that capacity hat off. You're changing the frequency of the coil.
Hmm.
So the size of the hat on top of the coil is there's a value to it. So you can use that as your floating common because you're out in the middle of this. It's everywhere. So you've got both ends. You got both ends of the circuit. I mean, I bet you could probably trail four wires behind the spacecraft and do some that are only going out 100 feet or a couple of 100 feet, and then do the others that are going further away. And then there's no way of them arcing. I guarantee you, the energy pickup is beyond belief. But I think they could do something like that. I don't know why we spend all this time in the space shuttle playing with plants. I mean, it's all important, but they should be pursuing that. And it bothers me why they were puzzled how the thing just disintegrated because it got overloaded with power and it wasn't pursued. They didn't pursue it again, and I want to know. I'm just like always wondered why. Why? What are they hiding? Because that would be incredible news. The space station wouldn't need solar panels on it. What do you need solar panels for? Just tether a cable out. Make your spacecraft your common ground, and that antenna is your radiator to pick it up.
Yeah, well, they don't want to tell you that because they want you to
No,
believe it's all solar panels.
no, but I guarantee you, there's something there.
Oh
You
yeah.
know, it only makes sense because it works here. We can produce it here. You got a bunch of Tesla coils behind you that you can do the same thing, just not in space.
Oh
Yeah.
yeah. Well, you can drive a rod into the ground and put one of these Tesla coils over it and pull energy right out of the earth. You
Hmm.
could put an antenna to one of these and pull it right out of the sky too. They
Yeah.
actually put a limit on the height that you can drive your drone in the air because people are taking it out, putting balloons out there, doing Corona motors out of it, stuff like that, and they're learning that it's actually working. And when you start coupling that with the ground and put it into a capacitor, and you can adjust the capacity of it, because you're getting more amps from the ground, more voltage from the sky, it'll blend into a beautiful, array of energy out of it. So yeah, it's really interesting that it's all free, and we even have the height of towers and everything to pull the energy right out of it.
Oh
And
my God. Yeah. Yeah. Um,
it, it said that the St. Louis
I was
Arch.
on a tower. Not to cut you on, Nathan. I was on a
uh,
tower time when I was younger. We were building a 400-foot tower, and so I'm riding a side arm. I'm riding a cable that's connected to a shiv that's on the side arm that's going up the side of the tower, pulling up another section of the tower so we can stack it. And that side arm is hanging off of straps. And I've gotten in between when I was switching off from the side arm, the gin pole. That's really a gin pole. Switching from the gin pole to the tower, transferring over, and the gin pole is just hanging on the tower on straps, and it's just floating. And I got jolted. I was lashed off, and it's a good thing because I got jolted just having leaving the gin pole and then letting that go. And when I let go and I got far enough away that the arc jumped from me, went through me into the tower. And
Ooh,
the tower was grounded as we were building, as we were stacking tower sections. But I got jolted just off a 20-foot section up, like, I don't know, I think we were like 300 feet or so stacking tower. And and I got jolted just by that 120-foot surface area. And it was, I forget what the Roan number was on it. It was a Roan tower, but I think it was a 4-foot face, triangular, 4 foot, and I got jolted pretty good. So the
oh,
higher you go, the higher the potential.
oh yeah.
Mhm.
Yeah.
Yeah, I was going to say earlier the St. Louis Arch, I said once they put that thing up, the weather changed. They were having a lot of weather problems. They put that thing up, and all of a sudden the weather in the area changed.
Hmm.
So they stopped getting too many thunderstorms through there. They stopped getting, anomalies up in there. Completely changed it. So there's something to that because it just grounds out to the from the ionosphere into the ground at that point. It's like a short. You know what I mean? It kills the energy in the air, so it can't build up too high, so it cannot create the weather anomalies.
Right.
It'd be interesting to see what the FCC would say, Tim, if you called them and said, "Hey, I want to put up a 400-foot radio tower, 1,000, whatever, and I just because I want it." I wonder what they would say to you. Like, "Oh, I bet they'd tell you can't do it legally." They'd have something to say.
Oh
Yeah, I'm
yeah,
sure somebody will have a problem with it.
you get a visit from the black suit guy.
Yeah.
That's what you're gonna get.
Probably.
Yeah. But I mean, imagine having possession of an AM broadcast tower. Um, that would be
Hmm.
pretty crazy to get access to something like that. In other words, that's not being used as an AM station anymore, and it's just deserted. And to have the right to go in there and experiment to see how much power you could really tap off that thing that'd be nice.
I bet it would be
That's
a
like a
lot.
bucket. That's a bucket list thing right there.
I wonder if you could find a property with an old radio station that was shut down like a long time ago that has a huge tower on it. Then you'd be set.
Oh my God, yeah, that'd be great. Yeah, yeah,
You wouldn't have to worry about the permit or nothing. It's already there, and you just tell them I don't
yeah,
know what you're talking about.
yeah. And you'd be off grid too, because you won't be needing anything from the power company. That's for sure.
No, you won't.
Nope.
Just get your conversions right.
Yeah. I had my property in Plymouth. Um, I had 40 feet of PVC in a year. I was doing I had a drilling company, so I augured a hole, and I had 6-inch PVC, 40 feet of that in the ground, and I just kept on telescoping. And I had it so at the base this winch would wind up the cable, and this telescopic PVC tower would come out of the ground, and they had all stops at different points, so I could touch 60 feet, but it was I would never have kept it. I always had it like right around 45, 50 feet. But I had 20 feet of plastic coated chicken wire hanging from the top down, and then I had a ground connection. And just with that plastic coated wire caught, um, brought all the way down, and then doing a spot gap into the Tesla coiler was, I don't know, maybe about this tall. It was a small one, maybe a 10-inch or 11-inch. But I used a spark plug with a drilled and tapped into an aluminum plate, and that was my heat sink, and that was my spark gap going into the high voltage side of the Tesla coil, and that primary produced enough power to light a 20-watt LED light. It was like one of the first LED lights to come out at the Home Depot, and it ran that for 5 years straight. Never messed with it. Yeah.
Just
So that's
40 feet.
just 40 feet in the air, 20 feet of plastic coated chicken wire with a good connection to it, hanging on rope, was all I needed. And that lit up the backyard. I had a little over an acre of property there, so like the backyard was lit up at nighttime every night from that one 20-watt light LED. You know,
Nice. That's so
yeah,
cool.
24/7.
Gotta love free power. Anywhere you can get it.
Yeah.
Tim, will you check the private chat real quick? Because I didn't want to say it out loud unless you just clicks where the comments are. Because it sounded like you started to maybe go into that a minute ago, but I didn't know if you wanted to talk about that.
So who are we talking about? Yanni or John?
No. Go to our private chat. Click
Oh,
private chat. Because I don't remember if you did that.
yeah, we did.
Oh, okay.
Yeah, we did. Yeah. Why, you want to talk about it?
Well, I couldn't remember if it was last time. Yeah, if you want to, because that
Well,
was
hey,
really interesting.
it's Nathan's show, you know.
Yeah.
I'm lost. I don't even know what you guys are going into.
The OG free. Yeah.
The first he wants to know if we talked. Did I talk about the first gen, free gen,
Maybe you did after I left.
last live? Well, I think it was on Faraday's channel. Or did we talk
Maybe.
about it on our?
I'll tell you what, feel free to talk about it. So, because I'm lost on what you guys are going with, so just go for it.
I'm trying to remember what live if it was for when there's on Faraday's channel, or the live that me and Flint did.
I don't remember. But
That don't matter.
yeah, go into let's see. Describe how it was running that camper, or I guess a little what you're willing to go into on that machine, because you had a lot of parts. You had Raytheon parts in it. Because I got some. I bought some of that. Yeah.
The machine had an 80-pound flywheel on it. It had two ECMs. It had a Samsung for a prime mover. And as far as the prime mover is concerned, I had brought out the neutral connections. Um, so the Samsung was running like a Bedini circuit on two phases. Um, and through, if you think of, geez, I don't know if I should share that. Holy shit.
You can be. There's a way you can be broad.
Wait a minute. I gotta figure out a better way. I can't. That's a.
I knew that's why I was trying to ask you
That's a.
privately, Tim.
That's a big one, boys. I don't know if I can do this.
Yeah, I'd poke the bear. I mean,
All right. So we'll keep the description. We'll keep the description as a simulated cap bank. Um, in a very crude form. That's what was controlling the prime mover. And the machine surged about it surged between anywhere between 150 to like 200 and excuse me, my legs cramping up. Maybe close to 300 RPMs. So it was a surge up and down, and depending on loading and how much you were taking from the flywheel, obviously it took that much time for it to build back up. So it was a very narrow RPM range. But when the machine got up to speed, that's when it would go in a mode of generating a spurt of about 1100 watts of energy. When it slowed down, collection stopped, and it started on its next build up, building back into the flywheel, and gaining its RPM back up to where it should be, and then the cycle would start over. Another spurt of energy would come out and charge into what I had was six 8D batteries. That was my 48-volt battery system, and that ran my it that charged 24/7. The only consumable thing out of the whole time I used it was the belt, the 1 inch timing belt that I had on there. No issues with the bearings. The thing just, that was, the timing belt was the only consumable out of the whole thing. Other than that, it just ran, and it charged a 48-volt battery bank, which ran a pure sine 48-volt inverter, and it not only supplied power for my RV, but it supplied power for my friends' RVs when they were up there. So my unit, see, from where the camp was, the closest telephone pole or the closest power pole was like 60 miles away. And it stayed like that for a long time while I owned the property over the years. So finally it got closer. The guy that I sold it to, he finally got power and this is like almost 20 years later. It's to a point where more people moved in. It was worth it for them to move power further into the woods. But these are logging roads were used for get to properties. So there was no incentive to run power down a logging road. So it took time. But that ran other RVs. That supplied power for other RVs, not just mine. My friends, that everybody parked one up there. I had a big roofed in area where everybody could just back in their RVs all the way around the center point of this open walls, two-tiered roof system. So we had always had a campfire in the center, smokers and stuff, and everybody got power off me.
Nice.
Everybody knew that that they couldn't tell anybody. If any friends came over, they'd be like, "Where's the power coming from?" It's, "Oh yeah, the biggest story was we got a generator running out back. Don't worry about it." And that's the way it was always dealt with, and nobody never questioned it. But a few people were smart enough to try and it's like, hey, where's all this power coming from? You know, it's like I know there's no telephone poles here, and it's like, yeah, we got a generator running. Well, where is it? It's like it's off. We don't want to hear it, so it's far away. Yeah. So that was the bullshit story that we gave everybody, and so there was, 8 guys that 8 of my friends that kept it quiet. They didn't want to ruin a good thing. They could go up and not worry about having a source of power and not worry about dealing with a generator. So everybody kept an eye on it when I wasn't there. Yeah. But it
Yeah,
ran.
and
It ran for
yeah,
2 years straight. Yeah.
Wow. Now I really wish you had the specifics you could tell us on it, because some of the runs like that with free energy, everybody wants it.
I worked on that for a long time, and gave it up, and then came back to it and looked at things in a different light, and then tried something else, and so it was all trial and error. Um, but yeah, there is. It's actually to loop a machine is what has to happen. It's simple, stupid. It's so stupid that it's like really literally out in the open. All you got to do is just you're capitalizing on every known thing that you can do, but there are some things that need to be treated a certain way. And then once you do that, it opens up a big opportunity to capitalize on and still maintain its own speed, keep itself going. Yeah.
yeah.
Can
How
you go
many
in
hours do you
depth a
think
little
it
more? Sorry.
Hmm?
Oh, sorry.
What,
I we
Nathan?
both talked at the same time. What was you asking, Nathan?
Oh, I just wanted to go in depth a little bit more on some of the things you needed to know for that loop.
I bet you do.
I did, yeah,
Hey, I'm
listen, baby.
trying. You
How
can't
many
blame me for
hours?
that.
Hey, Flint, I think this guy thinks he's Joe Rogan or something. I don't know what's going
Yeah,
on.
yeah. Well, how many hours do you think you actually had in that first generation before you got it to run? To put it in perspective,
Um,
why this is
from the
kind
time
of
I got it looped, let's see, when I first got it looped, I think I only had a 20-pound flywheel on there. It was a good flywheel. It was off a small little steam engine. Um, and the ultimately the flywheel, I had a friend that had a really big lathe, so it was originally a barbell weight that was 1/4 inches thick, and I think it was like 19 or 22 inches in diameter, 19 inches. I think it was 19 inches in diameter. Um, and so he chucked the thing in and turned down, left all the mass on the outside edge, and thinned it out from the center out. Um, Still structurally good enough to support on the shaft, but and then he milled out a lot of areas. So it was a typical flywheel, and I would say probably 80% of its mass was on the outside edge of the flywheel,
Mm.
and it acted nice. It really acted like a great flywheel. Yeah, but that's the key to the whole thing. You're What you're spending in the cost to speed up the flywheel, and then when your loading takes place, um, when you're filling the cap up or your condenser bank, that's an easier load than um, trying to run an inductive or a resistive load. So your energy is being stored, you're stealing time, and then you're giving it back. But in the process of stealing time, you're capitalizing on the momentum of the flywheel to a certain point from the higher RPM to the lower RPM. That duration time is the free lunch, pretty much. And then after that, you have to let it go and let the system build back up again. and then you tap it on the down cycle when it's spinning down. It's because of the load. So if your load, if the battery bank is up to volts and it's at its nominal voltage rating, then there's not a big demand anymore. The inverter would be running off the battery bank, which was flooded lead acid batteries, and the cost to do that. So your duration time changed. It was quicker when you weren't putting a demand on the system. That surge was up and down like literally like this, maybe 50, 40, 50 RPMs. And then when you started using power, that's when it went all the way down to about 200, 250 RPMs, and then there was a cutoff, which I could adjust it. And it's basically I had it labeled as stall level, because if you went too low with it, the system would stall and shut off. It would just kill itself. So the ECM has a natural characteristic about it. When you get up to when the ECM is used as a motor, there's a resonant RPM that they're rated at. Like majority of them are like 1,050 RPMs. Excuse me, that's like 1,050. So if you run that ECM at 1,150 or 200 or 250 RPMs, you're going to get the same output out of that ECM when it's being used as a permanent magnet alternator. But it's the cost to do it is easier. There's less torque. So I call it the breakaway effect, because you're breaking away from spending more energy to turn that at a higher RPM, and you're getting the same output. You're getting the same output that you were getting at a resonant RPM, but when you turn it faster, it gets easier at the same load. And that was one of the other effects that how the first gen works, uh, which is a huge effect that you're capitalizing on. So you need the flywheel to capitalize on that, to stay within that breakaway range, so that you can get as much power as you can out of it before you get to stall level. And then there's a disconnect, where you're not taking any more power out of the system. It's naturally wants to build itself up. And the only reason why it's trying to build up is because of the advantages that are taking place, with the leverage from the Samsung, from the center of the shaft out 11 inches. Um, so all these different things that you're capitalizing on allows the system to build up an RPM to a certain level. And then you're going to put a load on it again and bring it down close to stall RPM. And then you're going to get out of it, shut it off. You're not shutting the unit off, but you're going to do a disconnect where you're not taking any more from the system until it builds back up. So it's all done with different circuits to control all that. And I had it down to where it was just one potentiometer, or I was using that to control like a governor, in essence, but more like the lower limit, bringing down the stall RPM, bringing down the system to where it's just gonna jump out and disconnect at the right moment where before you stall it is the key. And you can set that higher. And if you set that level higher, then you're taking less out of the system for every spurt in RPM when it goes up and down. So it's a cycle. And in that cycle, you're just capitalizing for a moment, taking what you can out of it without killing it. And then it starts over again. So every 2.5 to 3 seconds, it's a give and take. It's giving to the battery bank, and then the battery bank's disconnected from the unit until it reaches its maximum RPM, and then it knows, okay, relay's triggered. We're going to close a contactor. Now we're going to start taking power and sending that through a bridge into the battery bank and start charging again. And I had accrued the limit on that was basically I was disabling the mag contactor before the AC connection going to the DC bridge when the battery bank at a certain voltage level. I had that used in a voltage regulator to adjust that for controlling it. So I can control in a very crude way that worked flawlessly, but in a simple form, just a cutout relay when the battery voltage was like at 51, 52 volts is when the free gen wasn't charging the battery bank anymore. It was like literally disconnected from it. So it ran in this idle mode where it wasn't doing anything. And it stayed, it's an unloaded situation, maybe 30 or 40 RPM change. It's just hovering at the top and it's only slowing down a little and then speeding up because there's no demand, there's no fight, there's nothing difficult to keep it going, there's nothing stopping it because you're not drawing power from it. Yeah. So you're drawing power from the system and you're adjusting that threshold to disconnect until it recovers and starts over. So it's not a continuous thing, but this cycle will go over and over and over 24/7. So
Yeah.
it's like taking your solar panels and pointing towards the sun and then putting them down towards the ground. 3 seconds later, you're pointing it back towards the sun again. Then you're pointing it back towards the ground. Um, as a comparison.
You're only taking out of it the excess energy, not the energy that would stall the system. That's why
Yeah,
it's
I
called
mean,
a stall.
you could take it all out, and then there's nothing left for it to recover and build back. So the stall RPM adjustment is you're adjusting that threshold um, just before you kill the machine. So you're preventing that. So it's a limit on how much you can look at it as a threshold to keep it from killing itself, or you can look at it as your charge rate, which you can only get so much. So it's a small window, but it's a big spurt, and it's just continuous over and over and over. You know?
Yeah, and I think I was the one that estimated it that first generation was approximately about 500 watts RMS. Does that sound right, Tim?
Yeah, yeah,
If
yeah.
you balanced it between its up and down cycle, because you were drawing a lot of load off of it, you were able to run your heat pumps that you converted, your RV
Yes,
stuff.
yeah, yeah. Yeah, it performed nicely. An easy 1,000 watts all day long, every day.
Uh,
You could push it to like 1,100 and almost just a little bit past 1,200 watts was a stall point. So I always had it adjusted because of worrying about being real cold up in Maine and tighter bearings. Because the machine didn't get warm. It never got warm. So it was always cold in the cellar because this was in the cellar of the fifth wheel. Um, so I factored in cold temperatures, and so I wasn't trying to be greedy with it. My thought was, it's like every 2.5, 3 seconds, I can get a spurt of 1,000 watts. What else? What do you need? There's nothing else you need. Yeah. So you got all those spurts add up. You all the reverse, and then my AC units, I had converted them to reverse AC, so they were acting like heat pumps. So it was my AC in the summer and my heat in the wintertime, and the that was I didn't have to worry about changing propane bottles or even bringing any of that stuff other than using it for cooking because of the gas stove. There was no need of that. Yeah. So it was.
It
And
almost
some
sounds like your flywheel was acting like a flywheel battery. It would get a
um,
lot of free spin, and you'd collect all the energy, and then you'd go back to work. And then,
Yes. So in that buildup of storing all that energy in the flywheel and building up and increasing the RPM, that was the energy I was grabbing The gyroscopics, the stored energy in the flywheel is what I was using to convert that energy into electricity through the ECM being used as a permanent magnet motor. And if it's running in its breakaway RPM, where the cost, you're still getting the same output, but at a higher RPM, so it's less torque to turn that generator. So the RPM drop is slower than it would be if it was a conventional type system, conventional motor with a conventional generator with a flywheel on it, where it was, it wasn't in its sweet spot. They would just slow right down, and that would be the end of it. Yeah. So.
So I'd like to show one of my videos. It's the one with the dual ECM surge on my channel. I had it private. I don't remember setting it to private, but I did. Do I just open that file when I click present, Nathan?
Yeah, present. It'll pop up on my screen. I'll put it on for you.
Okay, so real quick before we show it, this machine was not. It had a loop on itself, but it wasn't optimized. It was still drawing around 266 watts. But what you get to see is if you watch the meter, and I tried multiple meters, you'll see it look linear at first, and then in the moment you'll even hear a noise change in the machine. Once that noise changes, you'll see the wattage rises slightly, but on that meter you'll see a slosh effect where it will slosh all the way up to almost 900 watt surge. I'll go ahead and send it. I think that's doing it.
All right, got my hulls adjusted. Now it'll run.
Sound on it. You don't really need sound
putting
because
out
you can
about
see that.
18, but check this out. These
It'll take a
ECMs
minute.
will put out.
As soon as this power
Once
supply
it's up
goes
to a
up
certain
to
speed, so I
266,
might
that's when you'll
need to go harder 1-to-1.
So hold on real quick before we go any further. The motors that you have on there, they look like air conditioning motors?
Those are, yeah, that's what they are.
Okay.
They're ECM motors, repurposed as a generator. That's what Tim's used on his free gens the whole time. Yeah.
And not to sidetrack from things, but also I've got the other system that I've been working on for a while. That's using toroidal motor. Loves back EMF. The more back EMF involved, it just eats it like candy. It's crazy. And so a prime mover is a toroidal motor, and on each side of the clock box is going to be two 8-pole toroidal generators that are negating lensing. So that's going to be my prize build right there, because that's going to be an incredible machine.
Sounds like it.
Yeah, it's going to be, because it's really I'm taking the back EMF and let me put it this way. If I took the toroidal generator and resonated it, put all the coils in series and resonated that to its output, and spin the shaft actually aids itself. The moment you start creating back EMF, the opposite polarities and that's going on in the core and the magnet rotor is actually, it's aiding itself. So it's literally, when you turn it, it tries to turn it itself. It's taking the back EMF immediately as a tool like the bit would be doing, except we're using the back EMF as an addition to rotation. So you're negating the back EMF as a motor, and you're negating back EMF as a generator. So it's win-win. Using it as a generator and using it as a prime mover, the same thing takes place. So that will be a system that will be, I'll have to spend a lot of focus on controlling it, because that will truly be a runaway system immediately. Like I'm even thinking that that I'm probably going to put a pull start from a pull cord, or like for a lawnmower or whatever, or for a small gas engine. I'm going to be able to put a pull cord attachment on that with the clutch, with the latch, and be able to literally start it up with maybe just one or two good quick pulls, and it will take off.
Nice.
This type of thing you could take out in the middle of nowhere. Put that in your tent. It's not going to make much noise, and it's just going to be amazing. It really is. It's going to be amazing. And I need to finish
Yeah.
it.
The lock ridge was like that. Remember, Tim?
Yes.
That was
And what's
cool start.
nice, what Bedini doesn't tell you about the lock ridge is the capacitor, the lock ridge generator, which was your generator on the Volkswagen, was a Bosch generator. And the early 6-volt ones were 4-pole, and so you're taking the 6-volt out, and you're putting the 12-volt armature in there, and you're moving your brushes in such a way, they need to be really thin, so they're only sitting on one bar on the commutator, but you're creating phasing. And then with the frame of the generator being machined out, so there's a notch on both sides of it, so you got a north and pole flux coming off the Bosch generator, and with your capacitors are made and wound around that same area. So you've got a magnetic flux blowing into a capacitor, creating more copper electrons, and the capacitor was made with copper foil. So the original one that was used, that they made, and this guy that was making it, so the story goes, he was soldering. The older style televisions had these copper wide, like 2.5-inch or 3-inch bands that went all the way around the transformer, the power transformer, and that was to basically trap any stray flux coming off that, because that's going to be on the chassis of the TV. They couldn't have the magnetic field come off that, and affect the electron beam on the cathode ray tube, because it would distort the picture. So they ultimately, as the TV screens got bigger, they needed bigger transformers, and they had to kill the stray currents coming off of that. So he took those copper flashing strips that were basically went around the transformer and soldered to itself. He made his capacitors out of that, and used butcher paper as the insulator. I think it had to be at least more than one layer, maybe 2 or 3 layers, but that was his dielectric on the capacitor, which is kind of crazy.
Right. He never talked about that either.
Right.
Yeah.
So with your 4 brushes on the commutator, you're actually getting pulse DC. The output of this machine was a pulse DC machine, but supposedly it was good for about 300 watts or 250 watts. And then the only reason why that system worked, and it had a little flywheel right where the pulley was, and I guess they had a notch on it, and they could wrap the rope around it, and that's how they started it. It was started with a pull cord.
Yeah.
Really?
He said you couldn't pull 1 watt over, I think, 300, or it would just stall out and die.
Right. Yeah.
Something like that. Yeah. 300.
Breaking point. Yeah.
Yep.
Stall point.
Wow. All right. You want to watch the video real quick?
Sure. Yeah.
Jumped out of CC. Now we're good. Look at that production.
Starts right. If you can see it, it's pretty much linear right now.
But now,
not
300 now. Even 2.
Yeah, now it will. Watch that meter. And I tried it on multiple meters.
Now
I
it's
tried it
surging
on multiple
up to
machines.
800
and
watts.
Once I got a condition set up,
And that's
they
using
all surged
268.
like that, just like Tim was telling everybody. Now it wasn't in a loop state because I wasn't doing the other half of
These things are
the
putting
system
out,
like
man.
Tim was.
If that thing's right.
Controlling when
It
it's
looks like it was
dumping and when it's
fluctuating a
not. I just had a closed loop with no Sorry, I was reading that. It was just loop back. It was like a cheap way to do some tests, because that when I do tests like that, I do them really simple, and I'll do a lot of tests in like a couple of days. So it's like a lot of work, but I'll write down all the data, find out what's the most efficient, what's not, what gear ratios. If you look at those gears, I probably bought 12 different gears to try different ratios off the Samsung to those ECM driver generators. Yeah, I continue
Nice.
messing with it.
Sorry, I
Yeah,
turned the volume down so you could talk.
yeah, I couldn't even hear it on my end at all.
Oh yeah, we all heard it.
Oh,
Yeah.
No, so you have a Samsung drum motor on the end, and then you have two converted air conditioning motors on the other side.
Yeah,
Okay.
and when you say converted, it's really not converted. They're actually great three-phase generators right out of the box. All you got to do is spin it
Okay.
and collect. Yeah.
And when Tim was saying earlier he was driving the motor, was he saying that in the 3-pole system that they have on those drum motors, he only used 2 of them?
Yes, because what I was doing was I had the neutral pulled out, so I had access to that. And what I was doing was I was running 2 phases as a Bedini circuit, and I was getting my signal off the other phase. So my positive and my negative off that unused phase was my signal winding, and then that went through one part of the circuit to drive it for the electric switch, and which I used big transistors from an MRI unit. The capacitance value on that switch was I think like 2.5 UF, and so that actually resonated. It was like it was a marriage made in heaven, because the switch actually resonated the winding of the Samsung. But it was set up like a Bedini type triggering circuit, and so it took 2 pots. I had 2 potentiometers with the same value running on the same shaft, and that was my Bedini drive circuit. And what I did was, I don't know if I should talk about that. No, I'm not going to talk about that. So I just I drove the Bedini. Yeah, that's serious. Somebody did have to pay me like a lot of money to get that one out of me. But what I was doing was I was driving that Samsung when I needed to. That's about as far as I'll go with that.
Yeah, that's
When I
Tim's
needed
baby.
more when I needed more RPM, that's when I would drive the Bedini circuit.
Okay, hold on. So it's definitely a merry-go-round. You only tap it when you need to, and you still get everything out of it, and then you get a little bit back.
Have you ever moved an oxygen bottle across a shop floor?
I'm sorry, say it one more time.
Oh, I definitely
you
have.
Have you? Oh, I know you have, Flint. So, I mean, are you going to carry the oxygen bottle, or are you going to tip it on its side and just kick it with your feet once in a while, and just hold your hand where the cap or the top of the bottle would be, and just steer that tank to where you want to go, and you're kicking it once in a while with your feet. So you've got the stored momentum
I'll
in
be
that
right back.
bottle, and you're letting it slide through your hand right where the screw-on cap is for the top of the bottle to get to the valve. So you're letting that slide through your hands. So it's no effort. You're just kicking the bottle with your foot. It's turning it because you're kicking the edge, and you're just steering it off to where you want. So the Samsung with the Bedini circuit is very efficient, because you're only hitting that motor when you want to, when you need to, and then you take the power away, and then that's it. So that's how you're controlling it. So, and then so your Bedini drive circuit, the driver circuit for your input from your signal from your coils, getting the right pulse at the right time, um, you can adjust your drive level. So it all depends on how hard that. My governor circuit that I had on that controls the drive level of the Bedini circuit. That was my speed control. and then how much I wanted to put into it, and those were the kicks to the tank, to the oxygen bottle. So the spurts of energy that I would put into spinning that bottle were like the kick with your foot. Um, probably I think that's probably the best way of describing it. So you're not spending a lot of time. You're slapping the flywheel. You're slapping the flywheel when you need to get the RPM back up. Then you're not slapping it anymore. So you're not hitting it with your hand to speed it up.
Mhm.
Then to pull your hand away, and now you're tapping that energy. It's coming down. So the amount of effort that you're putting into it is not nearly as much as what you're taking out of it through time. And as long as you have your levels adjusted just right, it will recover and you can start the cycle over. You can just start it over. Then you'll tap it again. So you're kicking it again with your foot. You're kicking that bottle, that oxygen bottle. You could go across a shop like 60 feet in no time just by kicking that bottle and letting it slide. A real good flywheel is got all its mass on the outer edge, and that's where all the gyroscopic energy is at the maximum distance out over the center of that shaft is is the key. Yeah. So
That's like the
the
magic of the whole system, isn't it? That flywheel.
you,
Without it, you don't get a whole lot.
if you took yeah no as an experiment, I would take the flywheel off and it wouldn't do anything. I couldn't get it to do anything. It was nothing without the flywheel. It's nothing. You know, you might get it to run for just a teeny little bit, and then it's just slowly going to stop. Um, yeah, because you're putting everything you need to get into it to try and keep it going, and it's the wrong time because you're not at the right RPM. So the right size flywheel running at the right RPM to get that breakaway. The Samsung motor has all its coils and magnets on that outer edge, so you have leverage over the shaft. That's an advantage. It's all these little things that add up to something that's nice, nice anomaly. I'm gonna call it an anomaly. I don't know what you want to call it. Is it free? I guess so. It just keeps going if you don't disrupt it too much. So you take just enough energy out of it at every moment of peak, and not stall it, and then wait for the next cycle and start over. So it's and that build time is just a little bit longer than what you're getting out as a spurt as it winds down, but it's capable of building back up and start over again. It's capable of building its RPM back up, and then you just tap it again. You're taking the power out just for a little bit until the cycle starts over, and it just repeats over and over like that, up and down, up and down, up and down. But what's nice about the toroidal motor and the toroidal generator is um, it's gonna love to generate. It's gonna want to see it's gonna want to see the load on the shaft because it's gonna assist itself. So the toroidal motor assists itself. It's the only way I can describe it. When you power it, there is a little peak, and it immediately your input current is dropping because it tries to assist itself. So that wasted back EMF in a motor is being utilized as electromotive force at the right moment because it's a toroidal ring. Your rotor, your magnetic rotor, is going to be north south north south. So you have the right flux coming in at the right motor at the right moment, attracting your back EMF, which is the right polarity. So they're attracting each other. It's over and over and over like that. Yeah, that's as a generator. Then when you're being used, when you're using a toroidal motor as a motor, which is the generator, you're just using one as a motor and you're using one as a generator. My thought process, the way I'm looking at my new system is the toroidal motor is 4 pole and or 2-pole motors is the best way to think about it. But my generators are going to be 8-pole generators. So my frequency rate is faster than what I'm using for a 2-pole. I'm going to have an 8-pole generating current that loves back EMF, so it likes to load. And so that's going to assist in rotation and help it turn a little faster or make the job easier, like hardly any work on the shaft. So, and then the motor, the toroidal motor wants to see load, and automatically it wants to, because you're making it lag slightly, it's seeing the back EMF, and that's attracting. So it's assisting in rotation. It's literally win, 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 win. There's nothing wrong with it. But it'll be hard to control.
Fast runaway.
Yes, yeah, it's going to be. It'll be like the conventional system I had before with the bit, except and I couldn't even imagine running the power that I would use from that system to. I would use that what it generated, the toroidal system. I would use that to charge ultra caps to let that run a pure sine wave inverter. Yeah, right, straight from there. No battery bank, just the ultra caps. That's all you need. Everything will evolve around that.
Do you
So you
think?
get. Go ahead.
Sorry. Do you think you'll have a bypass on there that you can pull extra energy out of to put an extra load on it so that it won't do the runaway, but you can still capture the energy in, like, say, a cap bank with a motor on it?
Well, what I'd rather do is, I just want to have it controlled so it can maintain a certain RPM
Mm-hmm.
in its sweet spot, and not spend, don't spend as much energy in turning the motor. The toroidal motor is like almost like a rotoverter, but better. It really is. Um, a toroidal, a rotoverter would be the perfect prime mover for a toroidal generator.
Yep.
And that was done by what's his YouTube
M.E.G
channel?
hybrid.
Yes, yeah, the guy passed away
Yeah.
a few years ago, or whatever. His rotoverter system used 2 toroidal generators, and when I talked to him, um, he he wanted everybody to read between the lines. He didn't want to come out and say it. And then he's essentially, as far as I'm concerned, he has 2 loopers. He had 2 loopers. The 3rd generation machine he had with a toroidal generator on the disc motors. He had a toroidal generator on both sides. That was a looping machine. He never said it publicly, but it was a looper. Yeah. He only needed about 100 milliamps to run that machine. Everything was resonating. All his motor coils were resonating. His generating coils were resonating. And then plus he was tapping the toroidal generators, which had no effect on RPM at all. And he scaled the coils down on that with not so many windings on it, because his second model that he built, he was getting like 400 or 500 volts out of the toroidal generator.
Nice.
Yeah, he was shocking himself. He says it in the video. I'm tired of shocking myself. Getting poked, playing with it, But the beauty of the machine was, and I want to do that on my machine, on my toroidal machine, is doing the Tesla switch when you're moving one pole to the next pole on the rotor to the toroidal pole collecting coil. There is that moment where I want to short those coils out and only let them go in a perfectly timed moment every time, and let that energy release into rectify it and run that into an ultra cap system. Because when you short when you short the motor, the toroidal motor, or the toroidal generator, um, when it's being used as a generator, when you short it out to itself, it tries to literally, at maximum amount of energy that that toroidal generator is producing, is now trying to motor itself for a brief moment. For 1/2 cycle, it's trying to motor itself because of the back EMF. Yeah. So if you short it and then let it go, catch it through your diode bridge, send that to your ultra cap bank or through a voltage regulating system and then to the cap bank. That's the best way to collect all that. Yeah, the most efficient way. That's without a doubt looping system. Yeah. And then the other thing that I'm doing, I'm not going to get into the details how I have it hooked up, but for the toroidal generator and for the motor, mostly for the motor, when I'm taking power from the toroidal generator, I can vector it through a 1-to-1 transformer and tap more energy out than if I just tap the toroidal generator. So I take that energy out that I vectored through the 1-to-1 transformer and I'm sending it back to its cap bank. That increases RPM. And then I'm taking the back EMF from the toroidal generator, vectoring that through a step-down transformer. So the back EMF is going through, coming out, being controlled by one diode, and that's with the right resonating capacitance coming in, vectoring the transformer. I'm taking that back EMF out that's now out of phase, key thing here. And I'm taking that energy and pumping that back into the main cap bank. So it increases RPM again. So the more back EMF, the more struggle, the easier it gets. It just loves, like I said on one of my videos, the toroidal generator eats back EMF like candy.
Nice. Just so we're clear, the toroidal generator, you're talking about the Samsung drum motor, right?
Yeah. And no, yes, the toroidal motor, toroidal generator. Yes. Yeah.
Okay. I just want to clarify for everybody.
And that toroidal motor is running on a Bedini circuit. Again.
No, Nathan, I think y'all got it confused. He's not talking about the Samsung right now.
Okay, what are you talking about?
No, he's talking about another toroidal generator. It's on his YouTube. There's a bunch of videos.
Okay, I'll have to look at it.
Or you want to?
I can send you some links to take a peek at it. Just don't put it anywhere. I mean, if you want, you can download it yourself if you want. But I can send you an unlisted link of.
I just want to see the picture of it. If you have it on your page, then that's good. I just kind of want to know where we're at.
Actually, anyway. Hold on one second. I think I've got. Yeah. So let me send you a link.
Okay.
Nathan.
I want to say thank you, by the way, to Winona Ryder. Thank you for the $20. I really do appreciate it, man. And there is Easter eggs, by the way, all in that flywheel. I hope everybody was paying attention. That was kind of like the key element of what's going on here.
There you go.
I had trouble finding your channel, Tim, when I search it myself.
Really?
Yeah, it doesn't pop up. I'm logged into your YouTube right now, so I can see it. But yeah, you have one of your toroidal, I think, on there. More info at Patreon. That's one that you have public that shows what you're talking about. That's what I was wondering. I'm gonna get it logged out now. Log back to mine.
We're okay to show that, right?
Yeah.
Okay.
Absolutely.
Yeah, it's public. It's a public one.
Back EMF coming in should be a little faster now. Yeah, so 130. Take the back EMF off again, so nothing's being returned. from the back EMF.
Listen, I just want to take a moment and ask you to subscribe if you haven't done that already,
Here's my plug.
and share the video and give me a thumbs up. Those three things go a long way in supporting this channel, and I really appreciate it. Thank you.
Can you hear it speed up every time I put the clamp on there? It's literally like taking it has no idea that I'm taking that back EMF energy and putting it back into the system. It's totally the system is totally clueless of it thinks its power is coming from something else. That's the only way I can describe it. And then you're elevating that back EMF is going into the main camp bank and raising that battery voltage, that capacitor bank. It's raising that voltage up, and in turn, it's because of the Bedini circuit. There's more drive on the toroidal motor, so it tends to spin faster. It's getting a faster slap.
Gotcha. You're just pushing it at the right time with a little extra back EMF because
Right.
it doesn't know the difference. That's perfect.
When
Tim,
it
what
gets
you were kind of trying to tap the back EMF mechanically. Is that right?
well,
That system?
in essence, because of what's going on in the toroidal core, yes, it's nothing without the mechanical energy. But the when you're vectoring in the back EMF through that one-to-one transformer, you're creating additional back EMF, and because the generator loves the back EMF because it assists in rotation, at that moment, it's actually that the generator is acting like a motor because it loves the back EMF, so it wants to spin faster, and then at the peak of that cycle, I'm getting that power back the other way.
Yeah.
In the conventional form. So you get I'm collecting the back EMF from the motor, and I'm collecting back EMF from the generator. Plus, I'm using the power from the generator. But because I'm using the power from the generator and I'm vectoring through a one-to-one transformer, taking that power and sending that back to the same cap bank, every step is out of phase. So it's like an outside source coming in to the same junction to the main cap bank.
You're breaking symmetry on everything then.
Yes.
So it can't tell where it comes from.
No.
Oh, nice.
Who cares at the end of the day, though? It's coming in, it's coming from somewhere, and you're using it.
Exactly. Yeah.
That's the.
Yeah.
That's one of those little tips, by the way, that everybody should really, write down right there. Once you break that symmetry, it's free energy to use wherever you want.
Right, but you got to know how to do that. You just you just can't throw a bunch of crap together and hope to hit pay dirt, because you've got to you got to play with the reluctance of the windings. You got to it took a while where with the step down transformer and finding the right capacitance, you got a lot of work to do. But it's achievable very, very easily once you get on the right track. It's when you've got things tuned. The toroidal generator is all about resonance, and it doesn't care if you short it out for a moment, because if you do that at the right time, if you time your shorting on the coils for the toroidal generator, then you're assisting in rotation, which is bizarre. Yeah, it's almost like the generator's helping itself. And then the wasted power the back EMF from the toroidal motor is sent back to the source, vectoring through another transformer. And then you get a slight phase shift because of the capacitor value and the inductance of the primary side of the transformer, or the secondary side, which is being used as the primary side. And it's also a step down. It's an attenuation. You're creating a safe barrier for attenuation, so you're utilizing your high voltage spike and you're converting that into a lower voltage, more current through the step down ratio of the transformer. So you capitalize on everything that you can, and that's when the magic happens. Yeah.
And I want to, can I back up for a second, Tim?
Yeah.
Because I think you were when y'all started out talking about the bit, and you mentioned, you're using the bit as a tool. You're using it to phase shift the reactive power. What it didn't really get explained, but what I think Tim was saying, and correct me if I'm wrong, but if we're resonating at the ECM, or it doesn't matter, whatever generator you have, if you're resonating that and you're getting reactive power, you send that into the bit. Essentially, you're phase shifting your resonance back into where it's almost in line. And I think it's similar to when Bearden talks about his M.E.G being, it was 2 degrees out of phase, which means it's almost pure power. So your current and voltage are overlapping more. If it's 90 degrees out, you're pure reactive. So what the bit's doing is it's taking your reactive power, if this was the oscilloscope, and it's shifting it closer to 1-to-1. And it doesn't need to be perfectly 1-to-1 or whatever degrees it is, but the overlap at all right here is where you're actually collecting power back. You're actually getting to use that. And it doesn't break down your resonance because it's isolated with the bit. It's numb to what's happening.
Right.
Yeah.
Okay, so just so we understand each other, this is where physicists make mistakes. They think it cancels each other out when you have two waveforms right over top of each other, but it doesn't.
Though. It does in the conventional form. So if you have a conventional generator and a conventional motor, it will, because So I mean, you've got, say your permanent magnet motor is say 4 inches in diameter, and your generator that you're trying to spin with it, direct drive, say for instance, is designed to be driven by a gas engine. It's built and designed to handle the wrestling match that takes place in an alternating current. So and it can be the same forces, if not more, in the driving a DC motor as a generator. But those are conventional things, everyday items that are on the shelf. If you can take an off-the-shelf item, like we choose to use the Samsung. And the reason why the Samsung is so attractive is, you have your drum out here with your magnets and your stators, and you're 11 inches out, or 10 3/4 inches out from the center of your shaft. So your center of your shaft, you have this leverage point. So the Samsung, right out of the gate, it's the same RPM on the rotor as it is on the shaft. So it's the same RPM. So you have leverage because your coils and your magnets are out here. So you have leverage over the shaft. Same RPM. If you keep that thought in your head, now the main shaft. What am I going to do with the main shaft? Well, I don't want to lose RPM, although I've done reduction in the reduction ratio. But then you have to get involved with voltage multipliers to get your voltage back up. So direct drive is the best way to go. And if you're not going to do direct drive, then it needs to be a 1-to-1 ratio. And the less friction that you have in that connection, like as far as I'm concerned, like the ultimate transmission would be a magnetic transmission, even if it was just 1-to-1. So your ECM is being driven by a magnetic gear. And you got another magnetic gear on the shaft. That would be the ultimate system, because you don't have any friction involved whatsoever. So that's thrown right out the window. And then now, because you have magnetic gears meshing, you've got, your losses are lower that way. So that would be a great system. But as it stands, a 1-inch wide timing belt, 3/8 pitch, is you don't have to have that belt tight, to just tight enough so it doesn't slip over the pitches of the pulleys. you've got a nice low friction connection. That's the reason why I went with it. And then Flint's got chain. I've gone with chain. Well, ultimately for me, I was getting down to the point where I wanted quiet. I didn't want anybody to be able to hear it, and the belt served that purpose
Mm.
because it was a quiet running machine. If you stood outside the door of the RV, you didn't even know there was anything in there running. It ran so smooth. If you opened the door, you heard it. If there was chain on there, I guarantee you could have heard it. I didn't want I didn't want it to be discovered by the wrong people if somebody was nosing in around the camp. So if they unlocked it, you know.
So I drew this for y'all, the viewers. This is what I think is happening with the bit. Okay, the top one is just your resonance with no bit, and then you add a bit. Now look, you get your phase shifting forward, so you get more power out.
Yes.
That's it right there. It
Yep.
might be, I think it's mirrored inverted, but yeah. Sorry if it's backwards, but yeah, down here you're going to get more power out because the bit is phase shifting forward the current.
Mhm.
So
Yeah.
yeah,
Yeah, and that's for some people that don't understand, they look like two mountains stuck going next to each other. That's the one half of a sine wave is what you're looking at um, for your sine wave peak, and then your phase shift.
yeah.
So
I just wanted to, because I think you asked that, Nathan, and we didn't get the answer to it, but yeah, and those videos of that bit, who was the guy that invented the bit? Or
Fane Hines, yeah.
yeah, he
But
shows that,
again,
I believe.
though, I was doing that
I know.
long before he was still teaching. I think he was a professor. I think math was his profession. But I was doing that 10 years, or maybe a little more than 10 years prior to that. The same time that Doug was doing his coil shorting on his rotors was the same era that when I was messing around with the. I looked at a three-phase transformer one day, and then there's a three-phase motor next to it, and I'm going, you know, there's not much of a difference between the two. There really isn't. I think the transformer is more accessible, more usable, because again, it can be used as a tool because of the phase shift, and if you can make your input reactive and make your output real power, that's the key. And then you're not putting as much. Let me put it this way: that one bit I have, I could shut everything off in the house and have like maybe 100 watts drawing on the power meter, and I could plug that into the outlet, and I could go out and watch the meter stop. The bit would take the power and give it back just a teeny bit more than what you gave it. So it would literally counteract a small load very easily. And when you tune a three-phase motor into a rotaverter, you actually want to use. I told a long time ago I had got involved with this guy Reza, and uh, and yeah, I know. But I didn't think it ended up that he wasn't being a true person. So I'm just going to leave it like that. So I cut him loose. But he wanted to get a rotaverter in resonance, and it's like the only way you're going to do that is you want to go and buy an old school power meter that had the disc, and buy one of those on eBay somewhere, and that's your meter. That's your indicator when you can stop that meter and you're running your rotaverter. When you stop that meter disc, and if you can actually start making it walk backwards, then you know you're on the right track and resonating a rotaverter where it's starting to be almost doesn't cost you anything to spin it.
Hmm.
Yeah, yeah. But the three phase transformer is, I mean, it's cut and dry. Once you have it tuned, you know you only need to put this much in to get this much out because you're allowing with the shunt bars, if you put shunt bars on a three-phase transformer, the height of the shunt bar and the thickness of it is all critical. But once you find that magic combination and you have your shunt bars tuned, what you're doing with your shunt bars is if you're driving a three-phase transformer, you're driving coil B and you're resonating coil A and coil C. Now what you're going to do is the best way to put this. If you took the shunt bars off, it would be a serious negative. As soon as you put the shunt bars on top of the transformer and underneath, just letting it sit on it and then having the other shunt bar sit on top, you're creating a void. They'll rattle and make a noise depending on loading. And what I would always do is just super glue them down. But you're giving the back EMF to disappear for every half cycle for a brief moment to get out of the way, just long enough for your next cycle to start to produce more power again. And then when that cycle is completed, the back EMF that already come and bounced in and hit itself. So you've got a shunt bar here and here. This is the end, and then it goes like this. So it's like it's like a C, except it's upside down. If this was the top one, so the back EMF comes in the shunt bar and comes in and annihilates itself almost, but they hit each other because they're opposing. So they bounce back, and when they bounce back, the other half of the cycle has already been completed and it's starting on the other half. So now that back EMF is in the area at the right spots at the right moment, so it's a gain until the cycle starts to the other half, and then it gets pushed out of the way. You're creating a void for that back EMF to disappear and get out of the way, just long enough for you to draw your load, and then your input won't increase. You can load it up, and actually your input drive starts dropping when you start loading up your resonated output coils. So you take the shunt bars off, and it's nothing. It won't even work right. It's just going to be it's not going to act good at all, and it'll actually start getting hot. So you could take a conventional three-phase transformer and drive C and do nothing with B. Now B, that transformer steel on the B coil is your shunt bar. So now you're going to resonate A. So it's like a one-ended bit. When you don't have shunt bars on it, you're going to drive the furthest end, do nothing with the middle, and resonate coil A while you're driving coil C. That coil B, not the coil, but the steel structure is your shunt bar. So it's a single-ended bit. Is probably the best way to think about it. Where if you have shunt bars on the three-phase transformer, and they're tuned for the right distance for flux, then you can drive coil B and resonate A and C, and that will act normal. That will actually act better than a single-ended one, and with twice the power. So bits are amazing.
Hey, Nathan, I sent you a short. It's public. I just checked. I unlisted a bunch of my videos that I had closed down, but you can show that if you want. It's just a quick experiment where I'm showing it running almost completely silently when it's shorted.
Okay, hang on. So I have dual AC, ECM. That's the one we watched earlier.
Oh no, I did it a different way. I sent you a link in the private chat.
Oh,
because I'd have to dig for it on the computer.
sorry. Give me a second then.
Yeah. Let's remove that one. I'd have to dig for it.
No, I got it. It's a
Okay.
short. Give me 1 second. I got it right now.
It's short.
It takes a second.
Yeah.
Okay, so
All right, here we
it's
go.
hooked up now.
Now it's really quiet with all those shunts put on there.
I'm showing the back EMF
Yep.
shooting through those shunt
Looks so
bars.
crazy, don't it?
And that's the back
Yeah,
Okay,
EMF.
so it's hooked up now.
Yeah.
Okay,
Yeah.
so real quick in this setup, I see the 3 phases. So where do the shunts?
The shunts are the top bar that's a U. Looks like that on the very top and bottom. That's
Oh,
what
okay.
we're calling the shunt. Yeah. That's where the back EMF from A and C is shooting across each other. That's where you get the isolation effect. Yeah, and
Nice.
that
Okay.
that magnet just shows you that it is moving, and there's a circulating field up there.
Yes. Yeah, when you take the short off, the compass won't even move because there's no back EMF going in there. But when you load it up and you
Yes.
start to get your phase shift, then that's when the back
Yep.
EMF is getting pushed out of the way for every half cycle. Yeah.
So
Yeah,
I
it's a
made that
beautiful thing.
years ago.
That would come out nice too.
Yeah, yeah. I still got
I
it
think
somewhere.
I think you probably could have cut what were those 1 inch squares on the bottom you had, 1 inch cubes? I bet you could have
Yeah.
cut 3/8 of an inch out of there and lowered that a little closer. I mean, I could be wrong, but I bet you could have shortened that up so that the gap between the transformer and the shunt bar was a little less.
Yeah, well, yours was like that. Yours had actually a smaller gap than that, right?
Right.
And that's when it worked. Yours didn't work when you modified it. I remember you were really frustrated
Oh my
trying to
God,
get
yeah.
back to where it was. You couldn't find another transformer, and you're like, ah.
I'm scouring the internet to try and find another one. It's like I had to pick the rarest one out there because it's so hard to find. 11.1 kilowatt.
And for the audience, when I wound those coils, this is where it gets tricky, and you actually have to kind of be an engineer. If you're wanting to make something like this that actually performs something, even if it's not over unity, I had to match the inductive reactance to that iron mass. I had to calculate that. I think it was 352 turns of what is that, 24 gauge wire. And the B coil is getting the AC. That's also at 60 hertz because at that time I didn't have a variac or I didn't have a good frequency driver. That was when I first met Tim, and he said, "Oh, you got to make a bit." So I made one, and I still had to match all that. So you have to engineer that into whatever core mass you're doing. So you have to measure the core mass and then put it into your equations and then get the correct turn ratio. Otherwise, you'll melt the wires, the enamel right off the wires the moment you try to plug it in, because it'll be a dead short if you don't match that inductive reactance. So
Now, are the cores themselves special?
no, it's just transformer iron.
This transformer iron?
I made that out of a 3-phase reactor, 2 of them. I had to buy 2 of the same model, and one of them's the core, center core, and I had to 3D print the bobbins, which you could probably tell is pretty simple to do that. But and then I cut the other one down, and that's how I made those shunt bars out of the other one that was cut. So that's the way they're the same iron. It's the same everything, and I think it cost me like $80 for 2 of them. So you got to pay to play unless you go to a scrapyard.
What was your in and out on that, Flint? Do you remember what your input?
It was man, I don't know. It wasn't over Unity, that one, but the interesting effect I got with that, because I didn't have a pre-gen yet, I don't think, to even try to isolate with, but what ended up happening is I made that essentially was a 99% efficient step down transformer, which is pretty incredible in itself. Because when it's set up that way, you only get half the voltage back on either side unless you connect them in series. Then it becomes a 1-to-1 because the flux is split in half. So, but what was happening is since the back EMF was being transferred between the 2 sides, it was about 98 to 99% efficient as a step-down transformer. So again, it's a tool. It's a great tool. You could step down with it. You could make a isolation step-down transformer out of it, or a 1-to-1 transformer, or you could increase the voltage. You just have to do the math on the windings.
And that's basically you're running that right there at that point. You're not even resonating anything yet.
No, no cats whatsoever, and it was still 98 to 99. Yep.
Yeah.
But
So I mean
that's because
that's a good bit right there that should be incorporated with motor gen somewhere
I
along the
know I
line.
gotta find it, man. It's in a box somewhere.
It
Or
needs to
I
be.
can just build another one. It's not a big deal.
Hmm.
But yeah, buy
All
two
right.
more reactors.
I got a question for you then. I picked up about 20 of these. I got them for free. Would these work?
Let me see that a
Tim,
little closer. Your resolution just dropped on your video feed, Nathan.
Sorry. Give me a second.
I can't tell if it's an E-core. Looks like a E-core.
Oh, okay. That's that is a high pressure sodium ballast transformer. That's what that is. So that is T-shaped. So hold that still just for a second. You see that core that you have in your hand? That can be made into a MEG. That's
Okay.
what's interesting because you can make shunt bars out of that. Because look at where your welds are and where your gaps are. On the top, yep. So you got two welds. If you cut those out with a hacksaw and do a piece of steel on each side and do a nice thin cut just to get through those welds, you could split that core up. On the bottom, you've got so that center core is shaped like a T. Yep. So you could take that whole transformer apart, square everything off on a belt sander, and literally cut slices with a wood chisel that you don't care about, and nick the welds and make nice like 5/8 thick sections of core. And then what you want to do is in that center of that T, you take a chunk of that out for your magnet, and then that T is going to slide back inside where it is on the bottom, upside down. And then you can put your coils on your outside laminations there. Obviously, you're removing everything that you have in your coil right now. That's all history. Because your new coils will go on each bar on each side of that. But you could turn that into a MEG, and
Nice.
probably it if that was like 5/8 of an inch thick, that whole core section, that would probably oscillate probably right around 600 or 700 hertz. You can make it oscillate with the right number of turns on there, um, in the right position where the magnet should be going, which should be close to the top on one end. You could create you could create a MEG that would create DC pulses, and you can resonate both coils, and use probably Schottky and or a Zener diode, doubling them up and do a stack, daisy chain them, and you can in one normal regular silicon diode that will control the direction. But you can allow a fill up point where, and then your other coil will actually give a burst once it becomes in resonance at that cycle, and it would start the cycle over and over and over. There's Chinese guy. I don't know if he's Chinese or Japanese. I'm not sure. I had the video on my channel for a while, but I took it off. I could never get a hold of the guy. I put it on there hoping that he would get pissed and email me in the comments, but he never would. And that was the only reason why I had two of his videos up, deliberately, because he wouldn't communicate with me in his comments on his videos. So my last resort was to try and piss him off because I had a couple. I wanted to get his attention and I wanted to communicate with him in a sincere way, because I noticed his two videos, they definitely work, but I think he missed out on a small detail, and he had his old hard drive magnets close to the top, and if he just cut his cores a little bit different and lowered the magnets down a little more, he could have increased his output and still would have been free running. it still would have been exciting itself every cycle.
Nice.
But he never got a hold of me. So I get bored with it and then just didn't think it was right keeping his videos up. So I took them down.
That makes
It was
sense.
just his attention. There was another one that another YouTuber that's Russian, and I had his video on there because he didn't want to communicate, and that's why I put one of his videos up. And I converted his I used the YouTube Translate and had the text and did a screen grab and then re-uploaded it. And I had that running for a while, but there was again. I was trying to get his attention, and he never didn't want to play, so I took it down. Yeah.
Gotcha.
Yeah. Yeah. I gotta take off for 1 second. I got somebody banging on my door. Be right back, guys.
Yeah, that's cool, man. He moved this into a M.E.G. I saw the T one on his channel too. So
On Tim's channel.
yeah, he had that transformer. It was in a T, and he had the magnets in there. So I know exactly what he was talking about with this thing. Dude, I picked up a bunch of fluorescent light bulbs is what I went to do. And the guy goes, "You want a bunch of these transformers?" And I go, "Well, yeah." And then he goes, "You want this giant spotlight too?" I go, "Of course." You know what I mean? Who wouldn't want a giant spotlight for their front yard once in a while? So just make sure there's no planes coming over.
Had somebody delivering pizza to the house, and we didn't order any pizza.
Oh, did you get it for free or send them away?
No. He's actually, I think he's an illegal, and he's working for a pizza company and delivering pizza. Yeah, because he doesn't speak English. Sounds Venezuelan or something. Yeah. Yeah.
Wow. Yeah, I'm excited now because I got a bunch of these things for these transformers, man. Like I said, I got a whole crate of them for free.
Nice.
Yeah. Don't throw them away, Nathan.
Do you have it's not a Hall sensor, damn it, Gauss meter?
Gauss meter? For the magnets?
Yeah.
No, I don't.
I would get one. Get at least a 2% tolerance. You can get them from AliExpress, less than $100. Mine was like $60. I had a video of it showing it, but I can actually go get it here in a second. I know where it's at. But mine's a 2% tolerance, and it'll get you because you got to calculate your saturation for that M.E.G, and you got to get your magnetic flux just right, because that's where people go wrong. And Tim, when I first met Tim, he told me, he was in the comments, he was like, I think you're like oversaturating your M.E.G like maybe 10 times. And I'm like, oh, and then he started explaining it to me. And then I bought Bearden's book, and Bearden said the same thing. You have to be right under saturation, or about 80%, or it's not going to work. It'll work worse than a normal transformer. Yeah. And it'll be loud. So yeah. Yeah, when you make a M.E.G, you'll want to have a Hall sensor. Or you don't have to have one. You can vary the magnetic field by using shims, metal shims, plastic shims, or ceramic magnets, instead of just jumping to Neos, because Neos are significantly stronger than ceramics. That's what Bearden was using back in the day. A lot of those old timers back in the day were making loopers with ceramic magnets, pulling 10, 20, 30, 40, 50 watts off of it.
And just think, the Atlas rocket system used M.E.G to power the guidance system.
Oh yeah,
the radio portion of the guidance system they had M.E.Gs running. I've got that information firsthand by somebody that was their thing on their day, in their heyday, and then he told me, it's like, oh no, we used M.E.Gs. And they only had ceramic magnets. Yep, that's a nice one.
Yeah.
I've got to buy another one. Shit the bed on me. Yeah.
Yeah, I'm right there with you guys. I got so many tools sitting in this shop now. It's like my toolbox is overloaded, both of them. They're loaded, and then I bought a bunch of static meters and stuff like that for all the other projects working on. That was one of the one meters I didn't get yet.
Yeah. Yeah, I had just recently acquired, those carts that the stewardesses push down the aisle.
Mm-hmm.
Yeah. So I've got one that has. Well, I've just been looking on eBay because I want to get a couple more. There's five or yeah, I think it's either 5 or 6 drawers on each end. Open door, but it's a great place to store all your electronic components in. I'm amazed every time. I fell in love with this thing because it's on wheels. It moves around. It glides around. You put all your heavier stuff on the bottom, and then your lighter stuff on the top, so it's not tippy. Um, but it makes a great way of organizing all your electronics and still be able to pull them out and just get rid of it and push it out of the way. I was looking on eBay and the one that this friend gave me is like they want $1,200 for these things. And they're used. They're vintage aisle cots. Yeah, stewardesses drink beverage cots is like what they call it.
Mm.
But yeah, it's a nice way of storing stuff. I just had to throw that in
Yeah, no, I did the same thing. I bought a janitor's cart where normally they have the trash can in the front.
there. Yeah,
It worked perfect for my little gravity flyer project. So I could put my gravity flyer on there. I could stick my
yeah.
Tesla coil on the other side, you know what I mean? And still have a little station where I can work on and turn on every switch for the motors and everything. So I love those little carts. You know what I mean?
Did you
Different
ever
ones you can get.
did you ever get your gravity fire? I mean, did you ever get like solid measurements and seeing if you got started to get weightlessness, or did you ever get that far with it?
No, it didn't. There's no lift to it yet. We're not there yet. I got all the measurements of everything that the guy originally had.
Yeah.
That somebody bought it and measured everything, and we got all the information, motors, everything.
So the
And
original Russian version of that, the one that shows, really?
the one that lifted, yeah. So we got every
Wow.
bit of it, circuits, everything. And I'm
Hmm.
gonna tell you what, 99% of it checks out. That last 1%, that lift. All the rest of it's there.
Hmm.
Everything that he said, everything that he said would happen. Um, every test that he showed and why he showed it were self-explanatory once you got to work with it.
Hmm.
So I'm having a problem keeping the beat frequency in the craft because what happens is one side goes off and has it, the other side doesn't, and it kills the whole thing in the system. So your resonance is right, it's set. It sets an automatic beat frequency into it on one side, doesn't have it on the other. And I think I know why, because it's wire leakage and it's pulling the energy from it. And I took out one component that he had in there, and that was his connector bank at the bottom where all the wires are connected into. Because I thought, adding to morality, we'll just get rid of it. Well, stupid on my part, because that's where you picked up your beat frequency into it just by leaching with high voltage. So I have to correct that in order to make sure that it runs right. That way, it'll continue to build energy because it'll stop once it doesn't find that other side of that beat. It stops dead in its track, and it starts over on building up the energy. So yeah, I'm almost there on it. Been taking a while. I didn't think anti-gravity was going to be easy.
Right. Well, if it was, everybody would be doing it by now, right?
Yeah. All right, guys, it's almost 3 hours. You guys want to wrap it up for the night?
It's 3 hours already? Are you kidding me?
Yeah, it flies when we get talking.
Wow. Jeez, I feel like I stole the show. I mean, does anybody else want to say anything?
I mean, I'm good either way. It's up to y'all.
Yeah. Me too. I gotta go to bed. I gotta get up early in the morning. Yeah.
Man, I'll tell you what, you dropped a lot of information on us tonight. It's going to take a little while to sink everything in there just right. But that flywheel, man, you got me on that one because I've seen it do it. It was exactly what you're saying. I've seen it happen. So
Yeah, it's stealing time, stealing mechanical energy, getting out at the right moment, let it recover, and go back stealing a little more, and then let it recover.
it reminds me of shifting gears in the semi I used to drive. If you don't want to use the clutch, you have to put in your RPMs perfect and
Right.
get through all the gears.
Yeah. Then
Otherwise,
the synchros will do the job if you're close. Sure.
that's right. It'll
Yeah.
pull it in right into gear for you.
Mhm.
So
Yeah.
I just want to thank Ricky for the Old Man Build membership, man. Thank you very much. So, right on.
All right. I
Well,
just want to say one thing. When you can, go to the Heliarc channel and show some love over there and subscribe and maybe go to his Patreon. I've got a Patreon on my channel. And I'm sure Nathan has. You got Nate Patreon going on yours?
yeah, I do.
Yeah.
Yeah, let's we have a Patreon named Rod, and he started out on the 200 tier, and it was what was it, Tim, about a week, and he goes, holy shit, and then he
Yeah. I
upgraded
think
to the 500.
we overloaded him a little, but then he goes, "I want more."
Oh,
Yeah,
nice.
because you get access to me and Tim just like this, except it's one-on-one,
Right.
which is yeah, but you want to be experimenting.
wow.
You don't want to be sitting there with a pin. You know what I mean? You want to have some stuff so we can actually help you.
But he's a builder. He's worthy to keep my attention and Flint's.
Yep.
But I mean, it's just like we're I've done it for years. I've been basically paying for everything, and it's just gotten to the point now where I've people enjoy what we're doing. We've got to get something in return so we can keep on giving more. And
Yeah.
obviously, there's a cost for everything. I mean, Nathan, how much money have you spent in copper wire? You know what I
Oh,
mean? And how much you wasted just
Oh, there's
scrambling.
Rod.
yes, how
There's
much you
Rod.
waste learning? Yeah, there's a bunch of
Right.
spools.
I mean, there's a price. There's always a price attached to everything, and it's just like it would be so nice if we could be literally open sourced and uh, and do things that way. But um, so it's like the in group. We're looking for the in group for the ones that want to build, serious builders that want to build. You know what I mean? That want to duplicate what we're doing. Um, that those are the people that we're after because
So,
that's the way that can be preserved. It's just it's the best way of preserving projects. So many project nations. I don't know how many projects that you've looked at over the years that different people have done with Tesla coils, um, where they got fantastic results, but something happened to them, and or they passed away because of natural causes because they got too old, and there was nothing gained, and it was all lost. And the only way we can preserve what we're doing is by being subsidized by donations, and then people learning, taking that voyage with us,
Yep.
like subscribing to your club on your channel. That's a nice thing because the YouTubers they don't have to jump to another site. They can immediately support your channel, which is, I wish my sub count was high enough and my view count was high enough to be able to do that, but it's not. So Patreon for me is my only platform to help subsidize research. But what we're all doing is there's a price attached to it, and in order to keep it in the open, it's like we all need help. You know what I mean? And
Yeah.
the viewer is the one that gets the benefit by it, not the trolls, but just the straight up legitimate ones that are wanting to build. How many followers do you have on your channel that are building what you're building, Nathan?
oh, they're growing by the day. I have about 5 people who have already replicated the coil that I use all the time. And then I had another 5 people who I sold coils to, so they're working with them already. And it's starting to grow. I didn't put out my stuff until just recently. You know what I mean? Because I usually keep it to myself and just show you the results and everything. And people said, "Well, we want to do it. You know what I mean? Would you sell us a coil?" So I said, "Fine, I'll do it." And then what it does, like you just said, it helps fund the research on the channel. I need that spool of wire. You know what I mean? I may build a couple for selling for people, then I build a couple for me for what I need to do. You know what I mean? To make the tests work. But
Right.
yeah, I mean, it all is the same thing. I 100% agree with what you guys were saying. I did want to ask because Heliarc just said it. So you guys do one-on-ones on your Patreons when they contact you for like help on a build?
Yes.
That's absolutely amazing.
Yeah, we send them over to Telegram, where me and Tim are both on there. We'll put them in a group, and then, or we could do encrypted end to end. That's after we make sure they're not in another country using AI on us, which happens.
Yeah.
Yeah.
So we get when they on the lower tiers, when they click on the tier that's they're wanting to follow along or need consulting, there's a place to put a actual legal mailing address to the subscriber. So if they don't do that, they won't be getting anything. And I've got a couple. Actually, I got 2 awesome individuals on my Patreon. I wish there were more like them. But you know, it's like the costs on everything. It's like I just pissed through literally $1,000 of my own money on stuff because it's like I need it now. I don't want to wait. And it just gets old. Gets old after a while. I'm probably like in the 80. I'm probably like 80 grand I've got invested into all my stuff. And it just doesn't seem to stop. And it's just like, you know, and I'm 64 now, and somewhere along the line I want to retire, and it's like then you're on a fixed income. You look at things differently, and it's like I'm trying to plan ahead for that. Keep doing what I'm doing, and
gotta get him retired, man.
Yeah.
No, I get you. I took every birthday money, you know what I mean, Christmas money, everything to invest it in the gear, whether it be, you know, webcams or a better mic or, you know, a camera, you know what I mean, to shoot better pictures and stuff. All of it costs money. Yeah.
And I don't think a lot of you. And the reason why I wanted to mention this because I don't even know how many people are watching right now or are going to watch later, but it's this is like for guys like us, this is always a constant. It's always a wrench in the gear when it's like, oh, I got to spend some more on this. I got to do this. I ruined that stuff because of this project didn't work out, so now I got to spend more so I can redo it all over again in a different form. Happens. It's a lot of R&D and money, and it'd be nice. It'd be nice to see more people help support not just us, but other people doing what we're doing on YouTube. It's like I'm not a greedy person. It's just everybody needs help. Yeah, because there's so much more to give if we could, you know. But
I want to add to.
Who works for nothing? Who wants to work for nothing? I don't. When I go to work, I get paid. You know what I mean?
Yeah, but there's also kind of an untold cost, especially when you're working with the stuff that me and Tim are, and you can use your imagination here. There's a lot of people and companies and entities that would rather us disappear from this arena, and especially if you have a big mouth like me and try to push it, it can put you in danger. It puts you in the crosshairs. So that's something a lot of your viewers, like right now, I can tell they don't think about that. They don't think about what we're willing to give, but also the risk associated with just trying to give it. Like it's a mental toll on you. kind of looking over your shoulder sometimes. So yeah, it's kind of risky. Just like Nathan, I'm sure if you made a breakthrough on your gravity flyer to where, let's say you have a scale and it loses 20 grams of weight, are you going to be jumping at the gills to tell everybody about that? Or are you going to stop and think, whoa, is this a good idea? What attention might I get from this? So you have to play your cards very carefully. I'm not saying you shouldn't, disclose and say that, but I promise you, it'll cross your mind whether you should or not, because it's gonna, you have to reflect on, your own life.
That's why we're careful about what we say, because I mean we could easily let it all out of the bag. I own it. If everybody had the information, it's not that I don't want everybody to have the information. It's not the kind of exposure you want, because status quo is really not ready for something like this. So
No.
at a subtle level, keeping things at a lower key, and having builders like us, researchers like us, working on that same thing, and then they recognize the anomalies, and then they're discovering things themselves. But then that's a great safe way of spreading it out, so it's just not with one person. But anybody that comes along for a ride with us, you're gonna learn it. We're not gonna hand it to you. You're gonna learn it.
You gotta actually
You're
build
gonna
it
know it.
and work with us, and it'll floor you. I know that. What we have to give would floor you. I wanted to say another thing before we end this. So I have some boards that I'm going to develop, and Tim knows all about these because I sent him all the PDFs. But like this is one I have Grok helping me design. This will be a 600-volt field-oriented control driver for a Samsung. Will it be better than what we have? I don't know. But that's the thing. This is $600 for me to build this.
It could be. And you know what? That incorporated with the Bedini circuit, driving the Samsung, driving two phases like that. What's nice about the Samsung, Nathan, is this. The higher you go in voltage, the less current you need for the same outcome, or if not more. So the wash motor is a unique motor, where there's an exchange where when your voltage is going up, your current is going down. You get that nice curve, everything crosses, and it's very linear too. So the more volts that you put into it, the higher the voltage, the higher the drive level, the less current you need to run it for the same outcome, for the same torque on the shaft. So voltage is key.
It's got a different design, so it's centrifugal force on the outside, with the magnets being the weight that they are. You get a little better result than you do typically with a motor.
And the other great thing, I might just one more thing, and then I'll let you talk. The other great thing about the Samsung motor is, I mean, if you take those ceramic magnets out and replace those with Arc Neo magnets, that would literally be a game changer. Like, I guarantee you at 300 volts, you're probably going to be around less than 50 milliamps, or right around 50 milliamps to drive it. The same torque on the shaft.
Nice.
Yeah, we got to do that pretty soon.
It's a dramatic drop.
All I was going to say was, with the Samsung motor, Tim explained it real well, where you have what I call an inherent leverage. It's 11 inches in diameter, so you have 5.5 inches of inherent leverage that is always there. You can't get rid of it by nature, from the outer ring of that drum to the center of the shaft, to the center point.
Right.
Also, and you brought up a point, Nathan, that the ceramic magnets on the outside of that ring is also acting as a flywheel. So you're getting a little bit of two things at the same time. And also, a flywheel doesn't just store inertia. A flywheel, even if it's steel, if you have a flywheel at 0 spin, and then you spin it to, say, 10,000 RPM, that you will have an expansion of that flywheel, very slightly. It'll be microscopic, but that's part of it too. All those atoms are chained together, and they're getting stretched a little bit. And as it starts to spin down, Just like if you grab the inside of a merry-go-round and you pull yourself in, you start to spin and spin faster. Those atoms are doing the same effect. So you're actually getting like a spring-loaded effect with your inertia as well on the steel flywheel. So something to think about. Even if it's 10 thousandths of spring, you're still experiencing some spring at the atomic level because they're all chained together and they're getting stretched. You know, if you took that flywheel up to 100,000 RPM, it may fly apart because the atoms can't hang on no more. So they're just gonna shear apart. So yeah, this
Nice.
is my.
These are all kind of the tips and tricks you guys put into the Patreon there. That's so cool. Like I got to start doing what you guys are doing and talk to people one-on-one for the, you know what I mean, stuff like that.
Yeah,
I think
I
that's
mean,
important.
it's Nathan. It's literally an exclusive. You've got somebody that's giving you a commitment on a monthly basis. It's a private. It's like for my Patreon. I mean, it's not just me. It's Flint, and
You get both.
it's a three-way private that and then it's like eventually it's like you're communicating like buddies, and everything is just flowing out nice, and you get to learn from each other, but they're there to learn from us. Yeah.
And if I can throw a plug in, I was a welding and engineering instructor for almost 6 years. I have a lot of certifications online you can look at. So when a lot of people say, "Man, I like it when you explain stuff," it's because I've done it for a living, not over Unity. We didn't teach over Unity in the school, but I mean, I have a little experience working with people that have a hard time understanding. I can kind of go a step further than Tim in some areas as far as the explaining part. I can kind of take Tim's knowledge that he's trying to give, say, Rod or somebody else, and break it down a little bit further. And I think it's pretty effective. So as far as getting the information understood, you know, we can tell you the tricks, but if you don't understand it, all you have is wrote down tricks that you don't get. You don't understand what they mean. So that's what one thing too is we're trying to explain it where the person actually understands it. So that say if you did have a loop machine and something went wrong, say it's like even if we sold you one, say it was 20 watts over Unity, and you dropped it off the back of your truck going camping, and you lose the condition, and me and Tim are dead. What are you going to do now? You're gonna have nothing. You ain't gonna have shit because you don't know anything about it. So that's another point. If we want the technology to propagate and continue on after we're gone, we have to have other builders that actually know what's going on.
And there may never be a time to I don't know if society will ever. I don't think it'll ever be safe to be free about it.
Yeah.
You know, if you had a flyer, Nathan, if that thing elevated 1 inch off the table, that would be so much trouble. So much trouble. Yeah.
Yeah. You'd be getting your phone would get taken over. That'd be the first thing that would happen, and then you probably get knocks on the door for that one.
Yeah, it's crazy, and you know what? That would be serious research with an incredible result, and then but yet society isn't ready for something like that. The moment that we have answers from our government, what really is going on with UFOs, who's really behind it? Are we alone? Are we alone, or are we not alone, or is it our shit flying around? Is it technology from another civilization that's and we're working off of that? I don't know, but nobody's nobody's really seriously talking about disclosure. I mean, it happens in small forms, but yet still to this day, nobody's got a straight answer of truly the real story. And so for you, if it got a gram lighter, that would be trouble. if you publicized it. It would have
And
to be it would have to be a part of your in group of your club with with people that are working on that like that want to know how you got there, and that's when the platforms come in to make money, but also it helps pay for more, even more. It helps you continue your research. That's what all we're after. We just want to continue our research, and it just we all reach a threshold when you get so much stuff invested in and everything, and it's just like why am I sometimes I've said it to Flint. Sometimes I just feel like shutting my YouTube channel down. You can have all my videos, have fun in 20 years. I had enough. I'm not going to be public anymore because it doesn't seem like if it's not for Flint, I invited Flint along, and I knew when I saw what some of Flint was doing, it's like I told Gary, um, another YouTuber on here that he's passed away now, but it's like this guy needs to be on our team. And Gary was a brilliant guy as far as I'm concerned. He probably lived 3 lifetimes in his one lifetime because he did a lot of stuff, and a lot of stuff that he was a part of is affects everybody's lives in some way or another. Even just the way you get the news. Gary was the pioneer on teletext and how news stations got there and how newspapers even got their scoop. He designed that system. He was the circuit
nuclear
board
engineering.
yeah, he's just brilliant. But I mean, there's a lot of us out there. When I saw Flynn, it's like he's almost like Gary, but he's younger. You know what I mean? But I saw what he was doing, and I saw how serious. That's why Flint's my keeper of everything. Anything ever happened to me, he's the keeper of my stuff. Because it can't. Everybody that you hear over the years of all these different people, where is all Bedini stuff? Where's all his stuff?
Yep.
I would love to go somewhere that should be either in a museum, an Over
Hmm.
Unity museum, energy museum. It's like, where the hell does all this equipment go? Who ends up with it? Where
Yeah.
is it going? Why is it lost? And then it's a cycle that constantly starts over and over and over from one generation to the next. It would be, it's even nice to think that maybe some 8-year-old kids watching our video now, and we sparked something off that he will pursue for the rest of his life. What we do is we have an audience, and we're definitely motivating some people to want to do what we're doing. Hopefully, I hope so.
Yeah, I hope so. We motivate a lot of people that want to sell it. That's for sure. That's their
Oh,
And
key
then you
motive.
know what?
I want it so I
If
can
there
sell
was
it.
if there was a confrontation and what was left, the people that were left would be looking for people like us
hmm.
because we're the only ones that know how to come up with it with energy in whatever form that's going to be, however you're going to get it. We're the ones that are clever enough to be able to pull something off like that. It's just amazing to think that if you shut the grid off in this country, everybody is back to the cave days, and
Yep.
Well, not
you can't turn
all of
your
us.
shit on anymore. You can't talk to anybody anymore. You can't text because the tower sites are down. Just imagine the collapse of energy in its full form throughout the whole grid of the United States or the whole world.
Hmm.
Yeah,
Yep.
yeah. We will not say goodbye to the internet. People would be going through withdrawals.
Oh
I
yeah.
mean, they wouldn't even worry about food. They'd be worrying about trying to get online. It's insane. Can't
Yep.
watch TV.
Well, I'll tell you,
It's
with some of this stuff, you get kind of worried. There's people that just want it to make a bunch of money, and they'll patent your idea right away, and then next thing you know, you can't even work on it. So,
yes.
yeah, you have to worry about that kind of
Bingo.
stuff. And there's,
You
yeah,
you
We
hit
have
the nail.
layers. This is a pretty big onion that you're looking at. As me and him as a team is a pretty big onion that has a lot of layers, and a lot of those layers are security layers. So, not to mention we're like how many years? 7 years in advance, Tim, that we've been doing this. No, not quite that, but close. So when we get trolls, especially that's like that's never gonna work. Me and Tim are sitting back giggling because we're like, we may have done that like 5 years ago.
Yeah.
So it's like, who's really laughing at the end? Because
it's like you can tell somebody
they get frustrated
when they tell you the electrical engineer and what you're saying doesn't work at all. They're like, well, did you put your diploma on your toilet paper? Because that's what I'm going to wipe with later when I make it work.
I will clean the floor with them. Yeah.
Yeah, because dude, I'm going to tell you right now, I could twist things around so they work perfectly in cold all day long without a bit of heat. And sorry, you're the way you do conventional circuit doesn't work right, at least to me anyway. So no, I get it.
And sometimes,
sorry, go ahead.
Like I've had a handheld M.E.G, and everything I did to that to try and make it free run was like I said to myself one day, I'm gonna do the opposite. I'm gonna pull a 180 on everything I decide to do. It's gonna be the opposite, the polar opposite of that. And that's when you start to see things that shouldn't be happening if you think in the conventional sense that like, all right, this is a serious anomaly. So I got to keep thinking backwards and sideways because forward and is not working.
Yeah, well, that's the way a lot of the over unity circuits work that way. You won't find a resistor in them. You'll find a bunch of coils in them, and nobody bothers to read what the frequency of the coils were. Nobody looks to see if the NPN was running backwards or forward. You know what I mean? Did they trick it without putting the resistor in there? Or, you know what I mean, with some kind of light or something like that? And it's written all over these things. And as soon as you create the circuit that runs the NPN backwards, it's game over. You already know what they did. Every single one of them, I could tell you how they built it. It's ridiculously easy, but the electrical engineer that walks into the room who's completely wrong about it ruins the whole product. The whole party goes to poo when he comes in. Because he doesn't know what he's saying. Because he's never done it the right way. He always does it the wrong way.
Yep.
That's my opinion.
Yeah. I know some engineers will look at me and Tim's channel and they feel, just without even saying a comment or anything, they feel personally attacked by what we're doing. And I'm sure the same thing with you, Nathan, on the gravity flyer. I'm sure there's a lot of scientists that are like, oh, I just feel attacked by this because this isn't supposed to be possible. And in their heart, they feel like it's not, but yet they have not turned a single screwdriver and to try in that direction. They just immediately think, oh, my book said that it can't happen, so it can't happen.
Oh, yeah. I get that a lot. Yeah. So check this out. We usually see the Slayer exciter circuit for your Tesla coil, right? And they go out there and they blow up all these MOSFETs. You know what I mean? These E44 MOSFETs, and they explode them all. And they tell you, oh, well, you get a couple seconds out of this thing, right? I took a PNP and read it backwards like they're supposed to, and I get 40 volts all day, and this thing is a monster to handle. If you don't have 6-foot extension between your power source and the actual coil, you cannot run it because it immediately fries your power source. It's that powerful.
So you need a choke. What that tells you is, that tells me that you need a choke of the right inductance in between the power source and the switch. So you need a choke in there because that's going to pass DC one way, and it'll prevent damage. Yep. Got to have a choke in between the supply voltage and the switch.
Yeah.
So finding the right ratio is what you probably should try it. Yeah. Toroidal inductors. And then the other thing too is if you can find some nice iron powder toroid cores and make inductors on that, cut a slot in it, create a
Mm.
gap in that core. You know, and then you'll start to see it act totally different. And then you're gonna start to think about, well, what if I widen that gap a little more? Then it'll add even more inductance, more reluctance to it. You know, act like a better choke without even changing the line turn. Yeah, you know.
Nice.
So cool.
Man, this is
There's a
good
lot of things
vibe.
to improve that thing. Yeah. I just love it for the fact that it was so much power so quickly with so little part, and it puts like a lot of people to shame when they put this little thing on there and it goes, you know, this far from their coil and they're happy a light bulb turns on. You know what I mean?
Yeah, yeah, yeah. But they're learning, I guess.
Oh, they're gonna have to because it's a new age, and the way we build them now, you're getting tons of power.
Right.
Can I say something real quick? Because
Yeah, go
I
for
keep
it.
seeing these gatekeeper comments, and like as if we're gatekeepers. But those same commenters probably have not looked at me or Tim's channel at all or spent any time looking at the videos. Have you? They
No,
probably
I mean,
haven't.
no. You guys got a lot on your channel, to be very honest with you.
Exactly. If you actually went through and watched every video on me and Tim's channel, I know it's a lot. It sounds like a plug. Oh, go watch everything. Well, there's a lot there to pick up. And the people that say that kind of stuff, it's like they're the ones that are confused. They don't understand what it means to pick something up and actually try to do something with it with their own hands. They want someone to hand it to them or to be able to purchase it. And the sad news about any of these systems is it'll never be for sale. Unless the government comes clean and actually allows it to be for sale, it'll never be for sale. You'll never be able to go to Amazon and buy it. It just isn't going to happen. The moment someone tries, like if Tim tried or I tried, it's going to get shut down immediately and you ain't going to get nothing, because then what's going to happen is they're going to come down on us so hard that we're going to have to end everything.
But I'm going to say this just so everybody knows. We just had 3 hours of pure information given for free.
Right.
I mean, seriously, that there's some stuff in there that it's like just total bombs going off in my head, if you know what I mean. It's like, wow. Stuff that I didn't even realize was going on. And like you see little bits and parts of it, but you hadn't put it together yet. Oh, I got it now.
And you know what? On Nathan's channel, everybody that's watching this video again later, they should put this video on loop and just let it keep going around for days.
Yeah.
Increase Nathan's view hits and view hours, but drill it in your head at the same moment. Listen to it over and over and over again, because you're not going to recognize it until you got to watch the video and to the point where you know almost every inch of it on the progress bar. Then you're learning something. You've got to absorb it, and the only way you can do that is by repetition. That's the best way to learn.
Yeah, well, 100% agree. 100% agree. Yeah, it takes a long time, man. So funny. You see like a video, it's 3 minutes long, but the lead up to that video took me like, 2 days to get this stuff in the right position and the right resonance and everything else.
Exactly. Yeah. Yeah. That's truly what goes on behind the scenes. There's a lot of effort put into it. I mean, I've got enough video, or I could probably put like maybe, I don't know, maybe 200 hours of videos, and maybe shit, I could probably come up with, I don't even know how many videos I have unlisted on my channel. A lot that's not listed publicly, or they're private. But there's a lot we could have on there, but we just don't show it. Only a select few get to see it.
Yeah.
Yeah.
There's a lot of stuff. Sorry, go ahead.
If any of the viewers were in our position and you actually come to the same point that we are in time, you would be the same way. you would actually, I don't know how many of you would actually do what me and Tim are doing right now and actually trying to push some of it out. Most of the viewers would hide it and they would try to keep it to themselves or sell it. That's exactly what they would do. And
Well, I'll
deep
be
down, they
honest.
know that.
Yeah, I'll be
Yeah,
honest with
see,
you.
that's the perfect point, Clint. We're not trying to sell it. We're trying to we're trying to get subsidized just enough to continue on what we're doing. Like I'm not a greedy person. I don't want. It'd be nice to make $10,000 a month off my YouTube channel. You know, I could go on vacation or go anywhere I want, still buy all my shit, and still buy a lot. I'm not a greedy person, um, but I do want I do want enough help to be able to continue on. We all need the help. We all need to be subsidized. If it's, really at the end of the day, if you think of the global picture, it's like, so if everybody just pitched in 50 cents or 25 cents, if you looked at it for per capita or total people on this planet. So the percentage of those people that are interested in what we're doing is like maybe 1,000th of a percent of
Yeah.
out of 7 billion people. I mean, what is the actual number of interested people that doing what we're doing? What's that? What's that count? It's small. It really is. It's small.
Hmm.
It's almost insignificant. So that's that's our playing field to attract attention to those people that are willing to help and get knowledge in return. And that's all we're after. Because I just want to. It's not that I want to keep this game going, because none of us can do it forever. Everybody's gonna die. But I think what's nice about what we're doing is we need to preserve what we're doing. We can't let it get lost anymore, and we need to get to get to the get to the point where we need to get there quicker. We need to get to the point where we're coming up with stuff that's undeniable, but yet we're protecting it with a select few. That's the moral of the story. That's all I've ever been after. I think I wouldn't be sitting here right now. Um, we wouldn't be sitting here right now saying anything. We wouldn't even be on the show if we weren't concerned about letting little tidbits out, because hopefully we spark enough interest by more people that are willing to help, and in return, we
Yep.
get closer to the light at the other end of that tunnel. We're on
Yes.
a railroad track. It's one way, and we can't get off the train. And we're in the tunnel, and we're waiting for the light to come out the other end. We know we're at the
Mhm.
finish line, and to be able to have enough people on board that are on the same channel, and preserve things. That's the key. So when we have people come on our Patreon that are paying, that money that we get is going towards research, but they're paying to learn, and
Yes.
they need to learn it. It's not gonna be like we we'll lead you to the trough where you can drink your water, but we're not gonna tell you how to drink it. You need to figure that out.
Yes.
Otherwise, there's no point in any of it. It needs to be preserved. We we need to protect it, but we need to preserve it.
Oh yeah.
It's
Yeah.
true. It's like
Um,
it's just this is a constant battle between, and not that me and Flint battle, but a lot of our conversation on a daily basis is like, um, what's our next step? We're going to make the
Yeah.
right step, and we don't want to screw up, but yet we still want to get to our goal. You know what I mean? Which is ultimately, it'd be nice. Like when my toroidal machine is done, you will see a small, quick sneak peek of it, and that's it. And then it'll be unlisted or be private. And then maybe a year, I'll throw another little quick sliver of it out there in a video, and somebody else will get another peek, just to say, hey, this exists, but this is about as far as I can go with it because you know, you've got power companies and oil companies, you got nuclear
Yep.
companies, there is just too much money involved in energy on this
We've had
planet.
threats. Yeah, we've
And,
had
and
real
we're
threats.
and we're destroying we live in a bubble. We live on a rock that's in a bubble that's fragile, and we're on a daily basis we destroy. It's like living in a sealed home. You're never going to get to breathe the air outside because it's so bad, and we're ultimately we're ruining our environment we're pollution. Think about how many cars are on the road every day. Do we need electric cars? Yeah. Can our grid handle electric cars being plugged in? Do we have an infrastructure big enough to charge electric cars? No, no. And they don't want it. They don't want that to be. You know, they don't want that. They want things to continue on as they are until that last drop of oil comes out of the ground. And then everybody panics. And it's like, well, why didn't we do this and why didn't we do that? Well, there is a group of people that are way over there in the corner. That's us, and we're still doing our thing and trying to build a future.
Yeah. Our goal is for it to spill over so much. Like if Rod, for example, is one of our best Patreons. If we had 10 rods and they got up to our level, eventually it will, even after me and Tim are long gone, that knowledge can propagate out enough that it spills over to where it cannot be suppressed. That's the only way it's going to work. Yeah.
That's our only way. That's the only way that that it can be preserved in such a way where it's protected because that person had to learn it. They earned it, and they're not going to give it away. But they will teach somebody else, which is the hope that it can be mushroomed out in such a way where eventually it's preserved. But someday, whenever that day comes, when conventional science looks at over unity in a serious way and says, "Hey, maybe there is something there, working on it," you're gonna have. It'd be nice to see a bunch of people like, "Hey, we've been doing this for the last 150 years. We already got our shit. But what do you want to know? You know what I mean?" Then people can come forward with whatever variation of machine that they have at that moment in their life. Hopefully, there's enough of them to where we can keep this going on. But I know a lot of people that do research like this, energy research. In the back of my mind, that's always my biggest hope. That I hope that Flint, down the line, when he's my age, he's got 4 or 5 or 6 people with him, and then maybe that next generation, when Flint's gone, and when you're gone, Nathan, you've affected enough people that it's continuing. Whatever the results are, whatever the gains are, it's preserved and then getting better. And as technology gets better, so doesn't the materials. Like Tesla didn't have neodymium magnets. You know what I mean?
Yeah.
He didn't have any of that. He didn't have an oscilloscope. He had a crude ohms and voltmeter. He didn't have the equipment that we are so spoiled, but yet the majority of people still have nothing. He had little to no tools, and he had it all.
Yeah.
Yes, he had it
absolutely.
all.
Yeah.
Yep. And he had nothing to work with.
And by the way, me and Tim work normal job. How many hours are you working this week, Tim?
I'm probably going to be like, I don't know, 55, I guess.
Yeah. So it's not like we making money doing this. I haven't made a single penny personally to me yet on YouTube or any way, shape, or form. So a lot of the people getting frustrated, it's like, I don't care. I don't care how frustrated you get because it's costing me a lot just to be up here talking right now. So they can think whatever they want to think. It doesn't affect me. It's just going to affect their own emotions because they're not willing to take the time. They're not willing to buy a meter. You know what I mean? You're not willing to buy a meter to even try. So why get frustrated that you don't have all the knowledge?
Yeah,
Right?
I get draws and Tupperware, big plastic containers. That's like every time I go in my garage and I look at all my stuff, it's like holy shit. It's like I can't believe I got all this stuff, and it's like I have everything I need. But there's still something else you have to buy, and mostly it's materials, magnets, raw materials, in that whatever form that is. There are still some things you have to continue buying and to continue on. Yeah, and so that's the important thing. Giving, getting some in return, and being able to continue on
Well,
doing what.
I like I said earlier, look, I think you guys are doing awesome with the Patreon and stuff because you get a lot of one-on-one time, and that's so valuable. And it's hey, pony up a little bit of money, you get a lot of information, and you're going to work past the points that you normally stall out in a project. That's what's amazing. So I would never discount any of that, guys. It's the right way to go. I actually look at it as one of the best things I've ever heard with the Patreon, to be honest with you, because that's the point you need. Because a lot of people get to the they built this, they got there, they've succeeded this far, and they're missing that one little piece. You know what I mean? Hey, that little bit of money right there you would have spent spinning your wheels got you the right answer right there, and that's what they need.
That's what Rod. Yeah, that's exactly what Rod basically said to us. He goes, "Holy shit! I had no idea that y'all were like gonna hit me with all this knowledge." And then he immediately upgraded to a higher tier because he was like, "I want more. I don't know what the limit is." And Rod was so cool. We actually, I mean, we're very grateful that he moved up there. And that's for Tim, by the way, because I haven't accepted any Patreons really. I've directed them to Tim because Tim's deserves it. I have plenty of time. So yeah, we want Tim retired. That way we can do it full time for him.
Nice.
Yeah, for sure.
Yeah, I'm there with you guys, man. I love the members on my channel and the members of my Patreon and everything, and I try to do everything I can to put out all the information I possibly can so that they have it. And
And we see that. That's why we're here.
Yeah.
Because I think it's a great cause. I think what you're doing is great. That's probably the only reason why I'm here, Nathan.
Oh, I appreciate that.
Yeah. I mean, I've watched a lot of your videos, and it's like, I mean, I like you as a person, and but I also like what you're doing on YouTube too. And we need more people like us, that are dedicated.
We need to get excited. Get excited about learning again.
Yeah.
Everyone should be excited about it.
Well, yeah. I mean, that's what everybody tells me. We make it fun, we laugh, we joke, we have a good time, and doing our live streams, and then we'll just throw down some serious knowledge with some videos, and people are happy, man. And that's what makes me happy. You know what I mean? Come back, check it out. I mean, look, I'll be honest with you, man. Some of the stuff I do is absolutely hilarious and dumb and stupid, and I know that. Like last week, I was burning my face off with chicken wings and stuff, and having a good time. And the result of that was somebody got a Tesla coil for free. You know what I mean? So not only did you get to laugh at me, but you got something that I built for free, and everybody learns. So
yeah.
I like the situation we're in, man. I retired a little while back, and kind of keeps you going. This is my fun time. It's not so much work for me. Some of the videos are work, some of the learning is work, but this is fun.
Well, and people don't realize that even with your building a Tesla coil, like just getting one of your viewers to actually build their own Tesla coil from scratch is huge. They're going to learn so much from that.
Oh, not only that, they're teaching me stuff now. They're showing me stuff. I didn't realize the camera tricks and everything else on what's actually going on. And I'm like, no way. Okay. Here I'm feeling like I'm being left behind now because they're like way ahead of me. I got to catch up. I played with my camera for 2 hours trying to get that shot right to see, because he's got a fluorescent light and he wraps this wire around it and it changes to every color of the rainbow. And it all has to do with his camera picking up at the right speed and slow motion. And
Wow.
it was like, okay, that's significant when you're talking about heating gas and getting the colors of the rainbow. So that blew me away. And then I go over here. See, I can make mud conductive at 3 to 5 feet without a problem, just with my center of my Tesla coil. Like, that's just the small part of it. Wait until I get outside and we start playing in the big water. Then I could really show you something, man. That's the stuff we don't put on YouTube because they get really mad about it. Because
Yeah.
when you want to talk Colorado experiment, I knew exactly how to build it and exactly how to get that energy to pass a long way and just stick light bulbs in the ground and have them start up. I mean, you want to talk about atmospheric energy pushing into the water table. I know exactly the type of energy you need. It won't hurt anything. As a matter of fact, it'll help all the animals in the water. So, or fish, whatever you want to say. There's a different understanding here, man. The stuff that I can't even say because YouTube censors it. So.
Yep.
I didn't know Romero was on the chat tonight. That's a shame. I didn't even get to catch that. Did you see that?
Who's Romero?
Romero, and he's in Australia. I just saw
Oh
his
no, I
name.
didn't.
Yeah, I used to, Romero, UK.
Oh, he was in here?
Yeah.
I saw
Harold was
Rod.
in the chat?
Rod was
Yeah,
in the
Rod
chat.
dropped it. Yeah, we want Rod to be live with us one of these days.
Oh my God,
Rod's
yeah.
great,
He's another
He's a great
great one.
machinist.
That's
Yeah.
Well, you got the connection, man. My show's open. By all means.
Well, he's busy and he's probably a little nervous to do it, but we'll get him going once he gets his everything built that he's bought, because I don't know how much he spent. Probably several thousand so far just on the parts and stuff.
yeah.
Really?
He's impatient. We can help him with some of the parts, but he's like buying them brand new, and we're like, okay, well, that's what we're shipping addresses for. We could ship you some stuff. You know,
Nice.
that's something we don't talk about too much with our Patreon. Is we have source. You know, Tim goes to the scrap yards all the time, and he's got a great connection at the scrap yard.
Yeah, I mean, I've got people, I've got looking for stuff that I want, then they'll put it aside until I get there to go look at it and see if it's worth what I, see if it is what I'm looking for. But, yeah, that metal scrap yards are like the best. That's like, when I drive to Soho, it's actually, I'm going to throw a plug out there. It's Soho Recycling in Texas 3 in Dickinson, Texas. They're, when I drive there from my house, when I go there, I get the same anticipation, the same feeling I used to get when I used to go to Radio Shack. You never know what you're going to see in there. You know what I mean? I miss Radio Shack. But what you go in there, sometimes things are like brand new, not even a scratch. It's unbelievable. Motors, you name it. From scrap metal all the way up to electrical stuff, cabinets, air conditioning stuff. It's just everything. Sometimes it's in great condition or almost like new because it was scrapped, and there it sits. Just go in there with my tools and take what I want.
Yeah.
Nice.
Yeah.
Reminds me of pick apart back in the day, man. Working on my old Chevy, going there and taking out a whole bunch of stuff you want. Oh yeah.
There's still a pick apart in Oklahoma at LKQ. You can go up there and with tools like that in some of their yards.
Now they don't have old Chevys. They just have a bunch of foreign vehicles that are no fun for me.
Right.
Yeah. True.
Yeah. I used to do that, man, when I was a kid. We had a 2,500 square foot shop in the backyard. So from the age of 14, man, I'm out there building cars, ripping them apart. I had a bunch of Camaros, man, a bunch of Novas, Chevelles, everything. I must have owned like 30 classic cars and, built them, flipped them, you know what I mean? Tore out firewalls, welded in new ones, you know what I mean? Flattened them all out. Just beautiful things, man, you could do with those cars. So I've been doing that for quite a while, and I had to stop when I retired. So.
Mm-hmm.
I sold my last 72 Nova not that long ago. Beautiful blue color. So,
Oh, nice.
Yeah.
A light blue or a dark blue?
it was a dark blue. It was almost a different color. Yeah, when it was at night, it was like almost a midnight blue. It was
Oh.
beautiful. So yeah, I bought this thing then. Just drove it down to the park and went to walk. You know what I mean, around the track there, and then drove home. That's all I do. You know what I mean? In retirement to get my exercise. So yeah, it was fun, man. I love my old Camaro that I had a split bumper, but it had the extra part on the center of the grill, so it came out a little further. So it was in the 1970s. The rear end on that thing, man, when you swap that out for a 9-inch and then you put the meats on there, we're talking like this wide without tubbing. It was amazing.
Yeah.
So those things are pretty hot, man. Then you put it like a Z71 shock in there from a 91 pickup. And what it would do instead of air shocks is it give it that little bit of lift in the back to give you that nice rake that was like perfect. And then you could, put some coilers under there, under the rear end too. So yeah, it was pretty sweet.
The start of the muscle car era.
Yeah.
Yeah.
Yeah, those days are pretty much gone almost. Few rare ones going around, but they cost a lot just to buy a shell of a car today.
Yeah. And my generation's not interested in 70s, 60s, 70s, 80s cars really. They want the fuel injected newest thing, you know.
Let me tell you this, man. Getting a CUDA that has a real Hemi in it, like a real one, okay?
Oh God,
and yeah, you'll never ever think of a car the same again. Fuel injection, you'll just throw that stuff away, man. You'll sit in that CUDA and just lose your mind.
Yeah.
So
yeah, I like to have one.
Those days are gone.
Oh, love cars, man. Love cars.
Yeah, I have a coworker that was looking for just one of those miniature metal cars. They're like it was like a scale car that a kid could ride in it, the steering wheel and everything. And he wanted to put a wheelchair motor assembly and power system in it to drive around at like swap meets and stuff. And he's been looking for like 3 years and still can't find one. And he finally gave up on it. He had a wheelchair and everything, but he could not find an original metal car for sale. Everyone that's got them don't want to sell them.
Wow.
Yeah.
Well, you guys are in Texas, right? So Texas Metal out there, that shop. The guy that runs it, if I'm not, I don't think it might be the other one. No, it's the other guy. Texas Metal is the one where they do the 4x4s. It's the other guy that's out there close to him. He does fab work, and his metal work is absolutely the best. And he takes some of those pedal cars and restores them and gives them off the auction so that they can make money for charity. That would be the guy right there. That guy's amazing, man. He shapes that metal like beautifully, man, and he does it like old school style. You know what I mean? Yeah. I can't think of his name right now. I know exactly what it looks like, man. They got this big long driveway over there. They keep scorching it. You know what I mean? Putting tire marks on it with every car he gets that comes in. He's got to roast the tires a little bit, make sure they work right. So.
Yeah. It's nice, man.
Sorry. I watch a lot of car shows.
Yeah, I love cars. A lot of nice ones in Texas. A lot of crazy machines. Yeah.
Well, that's the last place you could be free. I live in California. There's a lot of Teslas out. Let me just tell you that. That's what it is. And there are charging stations here. So, like, this 50%, I think, are Teslas when you come driving out here in California. Yeah, where I live, it's bad, yeah.
How's that power grid handling it over there?
Well, we get a lot of brownouts. You know what I mean? You have to turn
Yeah.
off your air conditioning, stuff like that. Yeah.
Yeah.
And they don't relate the two in their head. They're just like, dude, have no idea. Oh, I got to charge my Tesla, but I can't turn on my air conditioner. They don't get it. So,
Yeah.
yeah. And then, oh, God, they pulled more stuff on the solar panel stuff's out here. You can't sell it back to the grid. Well, they never gave you a bill that you can read that actually showed that you paid it back to the grid. So now they're over here doing what was it, battery systems or something like that. It's a disaster, dude. But nobody knows what they're doing.
So Tim go green screen on us? Oh, there
Yeah,
it
he
is.
did.
I'm just messing around while you're talking.
Right on, man. All right, guys. Yeah, we're getting close to 4 hours now.
Yeah, that's it. I'm getting tired now.
I got to eat dinner.
Yeah, I gotta make a pizza. I'm craving some pizza right now.
We'll have to do this again, guys. You guys
Yeah.
want to come back
Yes,
on? Absolutely come
definitely
back on. Yeah, I'm going to work
Definitely
on
will.
that. I'm going to work on that. I'm sorry, not Bedini. On that transformer and get that T shape cut out and get that thing straightened out. Yeah.
Yeah.
I'm going to make that M.E.G, man.
Yeah, and if you've run into some check out carpet companies that sell carpet. Look for the tubes.
Oh, the good tubes.
Yeah, and then another I've looked at it just recently when I was in the Home Depot was the I know you want to go, Nathan. The the caisson tubes that they have at the Home Depot. I think I saw 12-inch. My God, what a nice Tesla coil! Like a 6 or 7 foot Tesla coil, 12 inches diameter, and that's a paper tube. Yep.
Oh, you're talking about for the concrete, those tubes, those big ones.
Yes. Yeah.
Oh, I didn't even
Yeah.
think about that. You're 100%
Take
right.
Yes, take a sliver of that and put it in the microwave and see what happens, and see if there's any composites in there. I doubt it. I think they're just paper.
Oh, man.
And you can buy
That would take
cardboard tubes, I think, at the mail, at post office.
Can you?
I think so. For documents, big documents, they sell the tubes for like $2. But they're small,
something?
not carpet
Yeah.
tube.
All right, you're making
Yeah.
my day now because I wanted to build a Tesla coil that got in the hertz. So
It's something to consider, Nathan. You build one with PVC, the same number of turns, make it identical to the one with the paper, with the paper tube, and if you get to coat the inside and the outside and really let it soak in before you put any wire on it, and make it really rigid and absorbed with your with whatever you're going to use, like a lacquer or whatever, you will be amazed because when you don't have the effect of the PVC is doing a lot of things. There's an aurora going on inside, which is a waste of energy. And then also internally in the plastic, you can have, because it's trying to act like a dielectric, but it's also shorting. So I guarantee you, a PVC Tesla coil, if you ran it long enough, I bet you could see that core warm up. It will. It
Oh,
should
yeah.
warm up time. Yeah, and that means it's wasted energy. You don't see that in a paper-based tube. It's totally different. Yeah, yeah, and you'll also see when you sweep an identical Tesla coil from PVC to paper, you're gonna sweep it and you're gonna find that it's resonant at a totally different frequency. Yeah,
Okay.
and it's
Yeah.
it's
I'm
it's just
definitely
something.
going to have to try that.
Yeah, you need to
Oh,
pursue
yeah.
that because it's a gain. It'll be a gain.
That's so
Yeah.
cool. Because I was thinking of getting a 10-inch wide pipe and wrapping it, right? Because I want to get this thing 6 foot tall. So that paper's perfect. I can go down and buy a big tube of that, no problem. Saturate that sucker in, some lacquer and let it dry out while it's rotating. That thing, you know what I mean, will harden up pretty good. Then a little bit of sanding, a little bit of, it's perfect.
And another way of I made one tube. It was I think it was 3 feet long, and it was I think it was 2 feet in diameter. But what I did was I put grease. Actually, I just brushed on the wheel bearing grease on the PVC tube that I had as the mold, and it was actually, I think it was Schedule 80. No, I mean no, it might have been. It was a heavy. I remember the PVC was heavy, but I used that as my mold, and I just used file, the paper that you use for files.
Hmm.
I would cut that up in strips, and I would build my own on that PVC, layer after layer. Just keep spraying it and layering it on. It takes a long time, but that was an interesting tube where everything that I was putting out, the output was just like it blew me away. The arcs were almost just as long as the tube. It would actually come down and start shorting out down at the base where the primary coil was, because the
Wow.
voltage was so high. Yeah, that's what you're going to notice. You're going to get more output, um, and you need to. I think if it was me, if I was doing what you were doing, I would get my hands on a high voltage probe. Every once in a while, I'll see them. If I see one, I'll send you the link, because sometimes I see them on eBay, where they're old school. Um, they used wafer bits, and they stacked it in this plastic tube, and the probe was on the end. Um, and that was the high voltage diode. I think it was silver and then a wafer. I forget what the material was, but it created a high voltage diode, and it could measure. I saw one that was like 100 million volts.
Oh, wow.
That's yeah.
Yeah,
It had the potential. You could dial it right down. Yeah.
that's cool.
It would to be able to, because if you can, for a Tesla coil, if you can measure the output in a way that you're attenuated so high in ohms, that you're not affecting its output. So in other words, you're not dropping, or your probe is not acting like a load. That's the key to measuring high voltage. When you can measure high voltage and your resistance is so high, that's when you're going to get an accurate reading, and your meter is not going to act like a load on the output. You're measuring real potential.
Hmm.
And that's a comparison to when you're tuning a coil, when you're sweeping it, and when you're trying to resonate your primary.
Hmm.
You want to monitor your voltage peak. Yeah,
Absolutely. Yeah, there's still a lot to
and,
learn.
and you can also, if you can create a baseline, just a baseline, and who cares what that measurement is, and you work off that baseline as a comparison to what you have with this Tesla coil and this one. Um, if they're identical and one's on PVC and the other one's on paper, as long as you've got a baseline, you can still calculate your output or your increase from one Tesla coil to another.
Yeah.
Yeah,
Well, that's what I want to do. If I can find a 4-inch pipe, I'll do that so I can measure them 1 to 1. You know what I
yeah.
mean?
You
And
could
see what.
take a 10. You could take a 10 microamp analog meter, a 9-volt battery. I've got a circuit that I built, and you can take a FET transistor and let that gate be your probe, and let the FET switch control your current on your meter. And at a predetermined distance, you could actually come up with calculations for high voltage measurement and not even touch the Tesla coil. Yeah.
Nice. Huh.
All right, I'm gonna get out of here, guys. It was a nice show. I enjoyed.
4 hours.
I'm gonna shut up and not talk anymore.
You're all good, brother. You're all good.
Yeah.
I
I
always
could see.
listen.
I see Flint. He's like, oh my god, he's
Oh, he's
talking again.
sleeping. He's ready to take a nap.
Yeah, I gotta get my pizza. first. But yeah,
Yeah. You didn't eat yet, Flint?
I ate earlier, but I'm hungry again.
Oh shit.
Gotta get it, man. All right, guys.
Yeah.
Thank you for hanging out with me, man. I really do appreciate
Yeah,
it, guys.
thank you for having us. For sure.
Yeah, right on. Have you back again anytime you guys are ready.
Yeah, we'll
All
do
right,
it again
thank
soon. It was good. Yeah, I enjoyed it. And
Right on.
anybody that happens to be out there for our viewers, thanks for coming.
Yeah, I
Yeah.
dropped you guys' channels in the chat all night, man. So,
Yeah, thank you.
Good.
Yeah, appreciate it.
All right. Cheers, everybody.
All right.
See ya.
Yeah, cheers, everyone.
The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.